Well, good morning, everyone. It's not quite 9 o'clock yet, but we'll get underway. Bit of introduction. I'm Dave Kripe, NM0S, the newly minted president of QRP ARCI, and nothing that I can do would really matter without the hard work of all of the club leadership that has served so faithfully before me. I'll call out Preston Douglas, who served very well in the years before me, and I see an awful lot of other familiar names in the participants list, the audience list. I stand in good company here. It's great to see everybody, so many familiar names and good friends over there. We all know the circumstances that have prevented us from meeting in person, but this day offers a lot of really good presentations, a lot of opportunities for us all to interact, and it's good to be here. Getting started, there are a few things I'll point out for those who have checked in recently. There are some buttons at the bottom of your screen which will be helpful for interaction as our day goes forward. For participants, there will be a button labeled Q&A with which you'll be able to interact with the panelists during the course of the presentations. There's also a chat window through which you can communicate both with me and the panelists and other people who are logged in. This gives us some ability to speak with one another, albeit virtually. And total of 8 presentations today. All of them I'm very excited about. A lot of really good material here. I'll encourage you also to come back at 7 p.m. tonight Central Time and Central Daylight Time, where we will have what I hope to closely mimic our evening sessions at FDIM, and it will be a free-for-all. We'll have Q&A sessions again with the speakers. We'll have representatives from clubs and vendors show up, and it may be a free-for-all. We'll try to make it orderly, but it will be a lot of fun, and we'll look forward to seeing you then. But it's 9:02, and time to get our day started. Welcome to FDIM 2021. It's not 4 days, so we designate the letter F in the acronym as fun. It will be a fun day in May and very enjoyable. I'll introduce the first speaker this morning, Tim Snodgrass. I've worked with him on a professional level for many years. He's done some very interesting things in the world of HF radio, and he's got some research materials to present, which I think we'll all find very interesting. So I will put Tim up as host and highlight his video. Okay. Bear with me. We're doing this for the first time.
You want me to do that? I've got it set.
Yeah, go ahead.
Look for KCDL 0DN.
There it is.
That's it.
Good morning. My name is Tim Snodgrass. I am Kilowatt Charlie 0 Delta November. I live in Cedar Rapids, Iowa, near the Collins Radio facility. I worked there for 39 years. I've been 43 years in industry and an amateur for 50 years. And, today I will be presenting the results of a 3-month study where I and 2 other researchers collected 64 million over-the-air measurements on 9 frequencies ranging from 2.5 meg up to 25. and over 1,000-mile path. And we're comparing that to what the Voice of America propagation program does. So with that, let's get started. Thank you. I've titled my presentation today, Breaking Free of the Solar Cycle, because there's a lot of good propagation and opportunities that we have found in our research, our over-the-air research, that is better than what VOCAP and other propagation programs predict. So the predictions are actually not as good as real life provides, which is good news. My brother, Charlie Snodgrass, he wrote software, the runtime software that's fast, acquiring the data, the raw data. And Mike Zato wrote post-processing software to take the data, the millions and millions of over-the-air samples, measurements, and convert them down to algorithmically to something that could be graphed. So you can quickly, by looking at a graph, see what the big trends are. So I couldn't have gotten this done without these two guys. They get a lot of credit for this. So let's go on to look at what we did as far as the 4 topics we introduced. The first one is I'll talk briefly about how VOCAP looks, how you read the charts, read the propagation prediction itself, so you understand that. I'll then introduce the hardware and software that we used to acquire this massive amount of data. And then I'll present some raw data and some process data examples from these 3 months of measurements we made over last winter. And then on a separate topic, I'll present some interesting phenomena that we found when we used circular polarization instead of regular straight wires, and used spatial separation between antennas instead of a single location, co-located antennas. So it's quite interesting. All right, HF propagation prediction. Everybody knows about the 11-year solar cycle, so I won't bother with that. Here is the output of VOCAP. And some of the inputs, a little fine print here. This is January 2020. Smooth sunspot number 0. I'm listening in Cedar Rapids. Fort Collins is transmitting, and over here, you'll find out that they're transmitting at 10,000 watts, which is what they're doing. So I have the antenna parameters in here. And when they get done cranking away on their program, they make a plot of frequency from 2 megahertz to 30 in the vertical axis, and the horizontal axis is 24 hours of time. Now, VOCAP only makes 24 calculations for an entire month. So in this case, it's the month of January. And for the month of January, they're saying that they have one value between 0-100 hours and 100 hours down here. And this is what it looks like. The colors indicate the signal to noise that you will find if you use, for example, 6 megahertz at 100 hours. It's yellow, which is greater than 85 dB hertz signal to noise. Now, if you come up here and you go off the chart, if you go above this black line, that's the maximum usable frequency. VOCAP says you can't communicate up here. It doesn't even bother to put colors up. You can't do it. It's not possible. The FOT, the FOT, the frequency of optimum transmission is the blue line right down here. So you can see here, this is the daytime. In winter, daytime is shorter than summertime. So here it's green and it's 80 dB hertz signal to noise if you happen to be on 10 megahertz at say 2000 hours right here. That's how you read the chart. So let's move on now. Here's the hardware. Here's half the hardware actually that was used. The top panel contains access to 5 antennas. This is the HF section, and this is VHF, UHF, and microwaves over here. Step antenna controllers for the 2 step antennas, 500-watt amplifier, 3 HF radios, VHF and UHF transverters and power amplifiers, flex receiver. Right now I'm running 2 flex receivers. One is monitoring all 8 of the 9 frequencies. We're monitoring simultaneously. And now for the big surprise, this is a radio array. of 8 Kenwood FT440s. And you can kind of read what we're doing here by the dials: 2.5 meg WWV, 5 megahertz, the time standard, 10 megahertz, 15. Then it changes to CHU out of Colorado. Below it are 9 816 megahertz processors that we use to acquire the data. Each one is dedicated to one receiver. They're coming down here, digitized at 100,000 samples per second, 12 bits. So we have good resolution, we have excellent timing, plus and minus 5 microseconds. Part of what we do is we measure the time of arrival of the signal from Fort Collins, Colorado, or from Ottawa, Canada. And we can measure and look at what's happening simultaneously when all these frequencies are transmitted from the Fort Collins facility in Ottawa. We can measure if there's a difference in refraction altitude as a function of frequency. And that's really surprising, but that's for a different presentation. And it's very surprising what we found out there. So we will not be addressing the time of arrival measurements, but it's all in this big monstrous database we have. To keep it accurate and dependable and stable, back here is a 50 part per billion 10 meg frequency reference that drives all of this stuff, all of the acquisition. Okay, here's the antennas. Here's a couple of antennas, 3 of the antennas, 2 240-foot crossed off-center fed dipoles. So a north-south and an east-west. This is a step-IR 3-element beam, and this is after the 130 to 140 mile an hour derecho came through on August 10th, 1 o'clock in the afternoon, and smashed everything. Bent the tower over my barn, and no, this isn't an optical illusion. The barn is actually pushed to the east, pushed out of alignment. So the antennas have been repaired. I will now introduce you to WWV, WWVH, and CHU in Canada, what their formats are on transmitting, and why we chose them to be the signal source. So why was WWV selected as a signal source for doing propagation measurements? The biggest reason is that they transmit every second, almost every second, and they have constant power out, and they cover the whole HF spectrum from 2.5 meg to 25 meg. And with CHU, you have 9 good frequencies in there. And you also get WWVH in Hawaii coming in on most of those same frequencies. So you're checking 2 distances with one waveform using different tools. So WWV in Fort Collins, Colorado uses 1,000 hertz sine waves. They have a burst. It has 5 cycles on the second. And then WWVH uses 6 cycles of 1,200 hertz. So you can deconflict them in the frequency domain. One is 1,000 or 1,200. And then on the minute is not 5 cycles, but 800 cycles long. And WWVH has 1,000 cycles, again using 1,200 hertz. So when you look at this in a recording, this is what you get. It looks like a bunch of noise. Blue noise, red noise, and green noise. But that's 10, 5, and 2.5 meg recorded over about a 9-second period. The brown marks on the top are a 1 pulse per second GPS signal. And the rising edge of that, the left edge, is the point that is the definition of the start of the second, according to the National Institute of Standards. And here's what it looks like when you blow it up. So you have this rising edge, and it takes 4.06 milliseconds to propagate from Fort Collins to Cedar Rapids, Iowa. But you can see the 5-cycle burst is distorted at 15 meg. It's looking pretty nice at 10 meg and 5 meg. And this is at 5:30 p.m. in August. So the sun is still up, sun's a couple hours from going down, and it's working well on these 3 bands. So this is what we record. We record this. Now, to detect the rising edge precisely, and to see what the signal to noise is, we do a correlation, a digital cross correlation, where we take a reference waveform with either 5 cycles or 800 cycles, or with CHU, we use 10 cycles, we use 300 cycles, we use 500 cycles, and 1,000 cycles. So that different transmitters are transmitting different burst lengths on different second numbers and minute numbers and hour numbers. So, right, so the correlation, it builds up. So this is noise in front. The waveform starts coming into the correlator, and you get partial correlations and anti-correlations until you reach this point where the whole 5 cycles is within and matching the reference waveform, and then it begins to decrease as the information, as the burst cycles through the correlator and drops off at the other end, and now we're back into noise again. If I sweep across this correlator, you can see that 1000 hertz is the only thing that's going to come through this correlator. Everything else is going to get decorrelated out here and attenuated. It's functionally a very narrow bandpass filter with a 3 bandpass of less than 2 hertz. So now you understand how we detect it, how we know what the signal to noise is, because we're looking at the actual percentage of signal that actually matches the reference waveform. So it really is signal to noise. It's a true correlation. All right, so here's the first example. We'll go back and pull up this vocap prediction we did from Fort Collins, Colorado to Cedar Rapids. So on this slide here, what you see are all the frequencies. So this covers everything that WWV is doing from 2.5 meg to 25. It's all on this chart. So this is the chart they have for the month I was doing this recording, last November, December, and January, the 3-month period. And when you just look at this, you'll say that this blue line, the frequency of optimum transmission, is where you get the best connectivity, best available channel. And this black line is the limit. You can't go higher than that or it's not going to work. So clearly 15 megahertz should never work between Fort Collins, Colorado and Cedar Rapids. If we did a graph, if we looked at that data on that channel with the receiver, you'd find out there's never any WWV coming in at 15 megahertz at any time. This is 24 hours during those months. Now, 10 meg should be working during the first 3 quarters of this. Should not be working. And then over here, it should work with signal to noise getting better and then worse. So let's take a look at what really happened. Really happened. Watch this. Okay, this is 15 megahertz, right? This is 15 megahertz predicted to never work to Colorado, from Colorado. And this is December 12th. That's the week ending. This is 7 days long. This is Hawaii, WWVH. And we're correlating on 1200 hertz tones here and 1000 hertz tones here on exactly the same frequency. And yes, this did arrive about 20 milliseconds after transmission, and this arrived about 4 milliseconds after transmission. But look at this. It says that every day of the week, you have some connectivity on 15 megahertz from Fort Collins, Colorado to Cedar Rapids. When vocap predicted that you would not have any by a large margin, okay? And yet look at the correlation. 92 million is what you get if you have full scale and you're pegged. So it's doing almost theoretic, almost as good as you can do from Fort Collins. And there's quite a bit of time. I don't know, maybe 20% of the time you could do this. Maybe it's 15 or something. But from Hawaii, vocap does predict correctly Hawaii to Cedar Rapids. And this is pretty close to what vocap is saying you'll get. So here's a case where at one frequency, vocap is doing it right. And in one case, the same case, 15 meg, it's not doing it right. So if I go back a chart, so this is not working to Cedar Rapids. I didn't put up Hawaii here. And so now we could check and see what 10 megahertz is doing. This is 15. And this is, what did I do? I dropped down to 2.5 megahertz, okay? 2.5 megahertz is at the very bottom of the chart, the lowest WWV frequency. And you can see that the correlation does drop off. It drops off and then goes back up. Down here, you'd say that there is signal, there's color here. there's color here, so it's working. And then what happens is, at this point, you lose the color, you get too low in frequency and it doesn't work. So my correlations are exactly opposite the way vocap draws their stuff, but you can see that they're saying that it's not working here. It's not working so bad that they don't even draw in colors and numbers. But the important part is right over here. If you get a correlation that's bigger than about 2 million, you can do modern amateur radio digital communications. Right, digital communications are viable. You can operate in this region right here where it says it doesn't work at all, but you can. Now there's going to be a couple periods where it drops below 2 million, but most of the time where it's gray down here, you actually can operate modern waveforms. You can operate JS Call or JS8 or something like that, or Olivia, Domino. A lot of the waveforms that have processing gain and narrow bands will operate here. So this is a case of a low end band working and then 15 meg not working. They say it doesn't work, but it does. So there's two pieces of good news here. 15 meg does go 1,000 miles in the daytime quite often. Every day there's a chance to do that. And 2.5 meg is working. And if you look at this, what it's saying, let me go back a slide. This says that I can operate 2.5 meg in digital modes 24 hours a day. 24 hours a day. And that is one of the things we have found, is that the lower frequencies have been underrated. Let's go on to 10 megahertz. 10 meg says it doesn't work here, and it should be working during this time where the cursor is drawing. And here's what the real data shows. So we have a very high correlation where vocap said we should have a high correlation. Where the waveform drops down when the sun, this is daytime, when the sun goes down, 5 p.m., what happens is, 10 megahertz does drop off. But here's what we found, is that after 2 or 3 hours, after the gray line sweeps over the region and it becomes dark, there's another window that opens almost every day where 10 megahertz is working again, and it's actually working with better throughput and higher signal to noise than it was during the daytime. And vocap says, no, that's not going to happen. And this is what it does most of the time. During the 3 months that we recorded, this is what it did almost every night. So the normative pattern was gray line screws it up and 10 meg recovers. Now, here's a whole week of December. And the brown lines here are where vocap says communication is not possible. And yet the correlation is quite large. I mean, there's a good correlation here. Most of this time has a big correlation above 10 million. Here's one place that vocap got it right. And here's a place that vocap got it right. It dropped down, it stayed poor all night. But here, nope, it came back alive after gray line swept through. Daytime, gray line swept through, it came back again. And here, gray line didn't affect it as seriously. The point is that there's almost twice as much in the 30-meter band, in this 10 megahertz piece of spectrum of throughput available, of time to communicate at 10 megahertz than we've commonly believed. It's really very good news. Now, look at this. Just in case you don't think a week's long enough to do it, here is a whole month. Here's a month starting December, a week ending December 12th, and down here is week ending January 2nd. And what frequency are we at here? We are at 2.5 megahertz at 1,000 miles. So you're looking at 2.4 million samples for 28 days, and vocap did pretty well at 2.5 meg, okay, at this distance. So they predicted, it's very regular per their 1 month average thing. We found that all these days were pretty good. They pretty much matched it. what was happening at 2.5 megahertz at this distance. And yeah, I had some software fail here, and I removed the coax. This was operator fault here, but you can see that it looks pretty good. It actually looks pretty good here. 1 whole month of 2.5 meg. It's not always present, but it's mostly present. It's mostly present. A lot longer than you would think. Let's go to the next one. Here's 5 megahertz. Now 5 megahertz was the big surprise in all this testing. We found that 5 megahertz was almost always open at 1,000 miles. In the daytime, nighttime, during gray line, in the morning, gray line at night, it was just a marvelous band. It was simply present all the time. There's a few cases over here where it begins to look like what vocap predicts, but not very often. Most of it is not there. Most of it is not there. A couple instances down here where it tried to get to be like vocap, but most of the time, 5 meg is always there. So the vocap prediction here is very poor, very poor. It's continuously open for 5, 6, 7 days at a time, even longer when you look at the other months. And no, I just couldn't stick 64 million samples on graphs and show you everything I wanted to show you. So, but there's a bunch of good news on this slide. Let's look at the next one. Now we're at 10 megahertz. And you saw a week of this. This is a month worth. It's the same month as 5 meg. And you can see that it commonly has that rise during the night coming back on. And it's very prevalent. Here, vocap got it right three days in a row. It did not recover at night, did not recover at night, same thing here. And then it started staying up. It didn't go below 40 million here. And just a little bit down, but only down to 20 million. So 10 meg is working better than expected most of the time. So probably 80% of the time, there's opportunities on 10 meg at night that we haven't been taking advantage of. When the band fails after gray line, yeah, we change bands. We go to 20 meters or something like that, or we go down to 7 megahertz and we're 40 meters for a while because 10 meg died. But give it 2 hours and 10 meg will come back to you. Okay, 15 meg. Now this, remember, we're looking at a whole month here. So the month started here, and you saw this. It's working very well, and vocap predicted it shouldn't be working at all. But look what happens over the course of an entire month. It gets more sporadic, and it comes, and pretty soon you have bigger regions of non-communication and more non-communication. And by the end of the month, there's lots of dead time here. As the month and the winter wore on and the sunlight decreased, it trended to be more like what vocap was saying. So you've seen what the waveforms do, what the connectivity and propagation does in the bands from 2.5 meg up to 15 megahertz. And now I'm going to show you something that is a synergy. The measurements show when you overlay 2.5 meg and 10 meg performance, they complement each other very well. So when 2.5 meg is down, 10 meg is up. And sometimes 2.5 and 10 are both up. But the point is that when you scan across this, you find that there's no place where you can't communicate above, say, 50 or 60 million. It looks really good all the time. So between these two frequencies, you can talk 24/7, 1,000 miles. So we're looking at 1,000 miles here. Now, obviously, a person could take this radio setup and then look at all kinds of combinations. I could show you CHU going north and east 1,000 miles, and then put Hawaii on here. So there's lots of things we can do, and you guys can do it too. You can look these up. You don't have to have a fancy thing, and you don't have to do 9 frequencies at a time. But with 2 receivers, you can build charts like this. It's pretty easy to do. So here's an idea of constant communication for, say, emergency or something like that. And you're still talking 1,000 miles, even when you go down to 2.5 meg. it's nice and strong. It is. Okay. Here is another, here's a blow up of that, and it shows just one day and how they interact as far as gray lag, okay, coming through and messing things up. So what it looks like is it takes a while for gray line to affect the frequency. And so orange 10 meg continues working past sundown at 5 p.m., continues working for a while, and that gives a chance for 2.5 meg to come up and be working before it fails. So it's really kind of neat that, you know, that this kind of stuff can be done. Normally this would, you know, you'd say, well, it doesn't work and I'll go do something different. But in this case, 10 meg is working, 10 meg failed, 10 meg is working. Just for this interval, yeah, you could communicate to the same place with nearly the same signal to noise. You're up above 50 million and carry on whatever you're doing. Again, for emergency communications, you can have a continuous connectivity. Now let's look at 5 and 10. 5 meg is kind of a jewel, a real gem. It does stuff that that is pretty exciting and unexpected. So 5 meg is blue, and you can see that it does go down. It goes down to 30 million, but you can operate at 30 million. You can operate at 2 down here. So, but you know, obviously the higher the signal, the higher the data rates. So when it goes down, 10 meg covers it, and then there's just a lot of possibilities here in terms of looking and using 2-band communication to have constant communication. So that's a good takeaway from this, is that if with some characterization and time, you could come up with a software program that would give you a high probability of communicating 1,000 miles in this case, just by selecting the right frequency. And it'd be very likely that you'd have connectivity to do that. Now, this is kind of an eye chart, but it was a fun thing. When I was analyzing the data, I came across an interesting fact. So here is a week's worth, it's 7 days. And I found that when 15 megahertz was open to Fort Collins, Colorado, 10 meg was always open, okay? The lower frequency was always open if 15 meg was open. Now, when 20 meg was open, 15 and 10 were always open. Now, 25 megahertz wasn't open very often from Colorado Springs, which is why I didn't show you guys the data. It's kind of a lot of dead stuff. But when it was open, 20, 15, and 10 were open. So in a way, you might say, you know, 20 meg and 25 meg are really irrelevant, because when 15 meg is open, it's good. I don't need to mess with 20 meg. If 20 meg open, I know 15 meg is open. 25 is open, 15 is open again. So these higher frequencies that seem like, oh, I go up to a higher frequency to talk further, not necessarily. Not necessarily. You can listen to WWV on 2.5 meg every day if you want, coming from Hawaii. That's right, 4,000 miles. All right, interesting things come out. Oh, in fact, here's the chart I just referred to. All right, now, this is 3 consecutive weeks ending December 5. So this is early December, and it's WWV. And remember this 2 meg correlation number, okay? So 2 meg is right here, second line from the bottom, and it's coming in from Hawaii. So I ran WWV, I ran vocap from Honolulu to Cedar Rapids, and it says when you're on 2.5 meg, look at this horizontal line here, it should never work. Vocap says that 2.5 meg should never get in from Hawaii. I have to go to higher frequencies to hear Hawaii. And yet, every day, there's good connectivity with Hawaii on 2.5 megahertz. Now, I came across this in the 1.5 years before we did this big recording, because I would hear I would hear the female voice, which is only in Hawaii. Colorado Springs is a male voice. It would be coming in, and it came in on 2.5 meg. Like, what's it doing here? That's not supposed to work. So the point is, with digital modes, you can have connectivity. You know, this cries out for store and forward. The idea that we used back in the 90s, 80s and 90s for communication, you can have reliable emergency communications with a few hours delay. And between 2.5 and 5 meg, somewhere in there, you'd think that maybe 160 meters and 80 meters would be really good, and we're not using them as fully as we could if we had this idea of store and forward available to us. Okay, let's look at Hawaii on 15 megahertz. So I just raised the frequency. It's the same slide you saw before, and I moved way up here to 15 megahertz, right across here. I didn't run me a line, but it said it should work and have, you know, certain availability across here. And interestingly, my measurements, my 3 weeks of measurements, almost exactly match vocap's prediction here. So they had they show 8 hours of good connectivity on 15 megahertz, and when I measure these, I average out at 510 minutes per day, or 8.5 hours. So vocap got this one dead on. It was right. So, but now it's 4,000 miles instead of 1,000 miles. So there are things that vocap does do well. Okay, now this is the same 3 consecutive weeks, December 5th, starting again, ending again. And now I went on 20 meg. 20 meg has been really dead. But look what we have here. It's occasional stuff, and you get some communications. Now 20 meg is way up here. And they said it should work. It should work as good as 15 megahertz. It really should. Between 15 is here. And the difference is you went from, I don't know, roughly green to roughly yellow. So there's a 5 dB signal to noise difference between these two. But in general, this is dead. I mean, even digital modes aren't working. Occasionally you get some through here, got above 2 meg for a while here. But across the board, in general, this is not working at all. So it predicts a lot more connectivity at 20 megahertz. Well, on 15, it was right. But at 20 meg, it's just completely off. So I don't know how you get confidence from using vocap for predicting things, because sometimes it works and sometimes it doesn't. This next section regards antennas and how they will affect performance. So I thought I should put on my antenna hat to make this presentation. Oh, it's always good to have an antenna hat. If you're going to talk about variations of antennas, you can try to improve your signal to noise performance when you're doing over-the-air testing. All right. First thing we'll do is define what we're doing with diversity here. There's 3 kinds, primary, that we can do, one of which is if you're working with linear polarization, you can use north-south and east-west. So those are orthogonal directions. The signals are coming down in a corkscrew fashion. All signals coming down from the ionosphere that are HF are circularly polarized. We happen to be receiving them on a linear polarized antenna because it's a straight wire, it's a straight line. So I have 3 axes there, and throughout this data acquisition thing, I would experiment with different types of polarization in the recordings. I'll go to a separate section on circular polarization. Spatial separation I'll show you first. And there's 2 antennas. They're both stepped IR verticals, and they're 5.6 miles apart. And here's what we look like on 5 megahertz. Okay, the blue signal is kilowatt Charlie 0 Charlie Denmark, which is my brother, and he is listening. His signal is blue. My signal, kilowatt Charlie 0 Delta November, is orange. And we found on this particular day that the signal at my location, he's in the city, I'm out in the country, that I did not dip down as far as he did. When his signal faded in the city, it didn't fade out here in the country that way. My signal was more or less, other than this event here, more or less fairly constant, and his was stronger than mine and also faded lower than mine. Stronger than mine, faded lower than mine. So it's interesting. I point it out because it's different, right? So if you happen to be in the city and you have somebody in the country, or just somebody 5 miles away, that you could link together his audio out via a 70 centimeter or a 2 meter link, you could be listening on 2 locations with physical diversity between your measurements, because if it's faded at my location, it's likely to be different at your location, maybe in a good way. Now, when we went from 5 meg to 10 meg, we found almost no difference at all. So it's just 2 data points that we came across. We have a lot of data points, but these are the 2 interesting ones. So let's look at this. This is triple polarization. So I have a vertical ground plane, it's 32 feet long, on top of a 40 by 60 foot metal building with ground radials, and then the 2 off-center fed dipoles. And this is quite interesting. It's 10 megahertz, and I ran 24 hours. Actually, I ran a week, but you can see some really interesting things here. You can see that the silver is the vertical antenna, and the silver antenna in the daytime is not as strong as the blue, which is the north-south antenna, at my location. The east-west antenna is orange, and it's weaker than north-south, but it's stronger than the vertical. But go over here to where the daylight ends and the night starts, the signals drop down, but look what happens. Both north-south and east-west, the wire antennas that are horizontally polarized, they're just dragging along the bottom down here. But the vertical antenna is actually able to pull up significant high correlations most of the time, and sometimes for long periods of time. And then, it's not obvious why, it fades away. And for a short time, the wire antenna is better, and then it comes back and the wire antennas stay better than the vertical. So the point of the chart is that triple polarization diversity can increase the amount of time you have good connectivity by, I don't know, maybe 30% or maybe 40% or something like that, versus I'm not working at all to, I am working, not as high as in the daytime, but I am working, and it's not too far below that. So it's intriguing. So it's another positive thing that came out of studying these propagation patterns, is that there's opportunities out there that we may not be taking advantage of. This is specifically about circular polarization, and this is the way the signals come down from the ionosphere. So when you receive them with a linear antenna, it's always going to be not as good as it could be, and you're subject to frequency selective fading phenomena. Now, here's what we did. We have 3 receivers here. We have 2 antennas. We have a north-south antenna, an east-west antenna feeding 2 separate receivers, and we plot those there. So this is a 6-minute circular polarization average. We have north-south and east-west, so gold and silver are the only 2 antennas. There's only 2 antennas in this experiment, and gold and silver are the north-south and east-west. So you can look at this. Gold and silver, these 2 here are the 2 signals coming in. There are no other signals than that. What I do is I take both of these and I perform a Hilbert transform on the east-west antenna, a 90 degrees frequency independent phase shift. And then I sum it together with the north-south one. So I delay this 90 degrees, 10 megahertz. What am I at? I'm at 5 megahertz. That's right, 5. And then I sum them, literally sum them together with a summer, a 3 dB summer, right? And then I plot it. And if you look, the circular polarization, the blue, is the summation, the Hilbert transformation summation of the 2 antennas, even though I have incur a 3 dB loss, okay? So I'm actually going through a 3 dB summing combiner, and it's gonna come out 3 dB weaker, right? So even though it's 3 dB weaker, it's stronger than either of the two inputs. Almost always. Here it is not, but it's just slightly stronger than them during the nighttime. This is 5 meg. Now, when day comes, 5 meg fades down to a lower value, but look at what happens with the blue signal. With the circularly polarized signal, look at what happens. As the east-west begins to fade, the silver one, and then north-south begins to fade down, the circular polarized waveform, when you recover it, I want to say this right, when you recover, it's the same signal. When you recover the same signal using circular polarization, it is not affected as much in the daytime. It just doesn't fade down deep, way, way, way down here, like these two linear antennas do. And remember, I'm taking these two signals, I'm shifting one of them 90 degrees, and I'm adding it together with a 3 dB loss. And look what happens. I get tens of millions higher correlation from these two low, weak signals down here. And then as the day begins to go toward nighttime, it fades back into being just a little bit better. So, this, if you look down here, there's only 12 measurements out of 1,404 where circular polarization is not stronger. So this is a big deal. This is very valuable, and it makes that 5 meg band, which almost works 24/7, work even better. I mean, that dip that came down that I showed you earlier, 5 meg does go down, but it's still usable. I mean, here we're dipping down to 10 million, but a correlation of 60 million is pretty nice if you don't want to go down to 10 million. So it's quite a discovery that we've made. And then we went back and we did a week's worth to see if this was a singularly unique, just one day it happened to do something goofy. But look at this. So this is nighttime. This is daytime. And during the daytime, when 5 meg is not supposed to work very well, it fills it in. It raises it from, say, a middle of 25 million up to about 55 million. It did it on this day, and it did it on this day, it did it on this day, this day. It's happening. It's always better. It's always bringing goodness to the party. Now, so at 1,000 miles, you can greatly improve your communication, the reception on 5 megahertz by the use of circular polarization by two cross dipoles summed with a Hilbert transform. Now, for completeness, I tried this at 3.3 megahertz, and the phenomena was only slightly there. I then tried it at 2.5, and it wasn't there. I tried it on 10 meg, and I did not find this phenomenon to be happening there. I tried it at 7.85, the CHU frequency in Ottawa, Canada, and it was slightly there. So it doesn't, in the limited testing I did, it doesn't happen everywhere, but it does happen. So anyway, that is, I think that's all the information I can squeeze into this much time. So the summary, what is the takeaway here? VOCAP is supposed to be 90% available, meaning in a 30-day month, it's in 3 days of it, it's not predictable, but the other 27, they claim that they're going to be right, and I found that was not the case. It's not that good. The second and third skip propagation, it doesn't model them. That 2.5 meg that goes and hops all the way to Hawaii doesn't model that well. After sundown, the predictions for 10 meg and lower are more pessimistic than the measurements show. We have a lot of advantages down there that we're not using. Circular polarization for reception has a lot of advantages, but only on the low bands. And so far, it only seems exceptional at 5, but I'll be doing more research on that. So hams have more spectrum, more viable operating time available than models predict. That's true. CW, QRSS, digital modes, many of these can operate in the lower bands independent. They can operate 24/7 down there. So today, gentlemen, the solar cycle is as poor as can be, right? We're down at 0 or close to 0. It's been 0 for months, and it comes up and gets up a little bit. But the point is, it's only going to get better. And over the air testing is showing that long distance, very long distances are possible every day. in the upper frequencies that are predicted to be dead, and in the lower frequencies that are predicted to not work. So that's the presentation, and we'll be open for questions now.
Okay, thank you, Tim. We do have a question from Neil Ormos, N9NL, who asks, can the vocab predictions be corrected by some understandable systematic adjustment to the input parameters or to the output? I.e., as a trivial example, by changing the reported transmit power by 20 dB or adjusting the MUF by some fixed amount.
Okay, in answer to that question, when you start changing the power numbers, the vocab, as well as most of the propagation prediction tools, use an old Fortran core, and they have certain parameters built into the software itself. And if you raise the power, nothing changes but the colors on the chart. The connectivities don't change. So if you're in that gray region, it doesn't matter how many watts you put in. I raised WWV to 1,000,000 watts and nothing changed but the color. It still did not show any connectivity in those gray regions. So no, you can't. As far as being able to correct it for propagation where it is working and it just doesn't predict it correctly, no, I've not found. I've used it for 20 years and I have not found that that even the long-term averages are correct unless you get the right band in the right situation. So I have had professionally, I was involved with a 42-day test, continuous for 42 days. And on the frequencies we chose, it was right on. It happened to be right on. So California to Hawaii and California to New York, on those frequencies, it did predict it well. So it's a Watterson model, which has a single ray and noise, and that's just not how the ionosphere is. It's much more complicated than that. So no, you can't correct it.
Okay, very good. Do we have other questions for Tim?
David, there's a couple of more in the open.
Oh, I see them now. You want me to answer these?
Yes,
Sure.
please.
I regularly use Whisper and FT8 spots to do this. I've made a database of Whisper communications and I've pulled out and I've tracked. I have a whole presentation on that. But Whisper is excellent because you get an idea of what the power from being transmitted is. You know the location, you know the angle and bearing. So all that comes in, and I've made two-dimensional plots where you can see rings of communication. You can see the blank spots where you're skipping over an area. It's excellent. Yeah, I've done that. That's very good. Is it worthwhile trying diversity with HF6 vertical and half wave for my Flex 6600? Interesting. Yes. Boy, depending on the frequency, but yes, it is. Diversity is always good. The real issue is when you have these two independent orthogonal type signals coming in, how are you going to combine them? So how are you going to combine them? But yes, I definitely use my step IR vertical and one of the wire antennas and combine them and get different. It's always better. The big beauty of diversity reception is, especially orthogonal, is you can almost prevent the formation of frequency selective fading, which is important. It's caused by the straight antenna being hit with a circular waveform. Next question is, if vocab is so inaccurate, what should the average ham use? I would encourage you to get Eric Nichols' book. He lives in Alaska. just outside of Fairbanks in a place called North Pole. He has done a lot of research on this, and the one he uses, what is it called? PropMem Pro or something like that. I'd have to check. I'll pass it the answer to Dave. There is one that includes a better modeling of the ionosphere, multiple rays, and also the effects of the magnetic field, because vocap does not include the effects of the magnetic field. So vocap is not predicting a circularly polarized wave coming down when you send a linear polarized wave going up. And everything coming off the ionosphere at HF is circular. Actually, it's elliptically polarized, except for the magnetic equator. So yeah, I'll get that product to Dave. Let's see, can we translate these results to QRP levels? Actually, you can. You can. When you lower the power, you lower the power, right? And at some point, you run out of processing gain, but you can certainly do that. Could the lack of improvement provided by circular polarization signal recovery be the result of operating antennas? Yes, you're right. My off-center fed orthogonal antennas droop. So although I have circular polarization, I have issues because they're not really straight and 90 degrees apart because they droop down. So that is the one thing I took away from 10 megahertz not working, because Eric Nichols has done this. And in his 2 books, he mentions this, and he used straight perpendicular solid rod antennas on 10 megahertz, and he got benefits from circular polarization at 10 meg, and I didn't. So I think it is my antennas. I think you hit right on it there, that I need to come up with some nice straight antennas at the higher frequencies, because my wire antennas are drooping too much to really maintain the orthogonality. Last question,
Okay.
it seems like.
Tim, I'm going to break it right here.
Sure.
We do have a little more business to attend to before the next hour.
Okay.
I'll encourage you all to either, continue the Q&A offline during the next presentation, or come back this evening when we'll have a chance to resume live Q&A. Tim, I'll ask you to return the host privileges to me if you could.
How do I do that?
Up in panelists, hover over your name and or my name.
I'm not.
I think you hover over your name and then click on host,
Yeah.
return host.
I'm not seeing it, Dave.
Okay.
Go to participants.
Participants.
And then panelists.
Oh, okay. Hover over my name and what?
Or over my name.
Dave Craig. Okay.
And then click more, and that should open up.
All right. Make host.
Yes.
You have the power.
Hey, all right. Well, our next presenter, Jack Purdom, has been waiting in purgatory here. I need to promote him to panelist status. There we go. Jack is now a panelist. One of the great traditions of, let's see if I can get my picture back. One of the great traditions of FDIM is a very lucrative selection of door prizes, and that is certainly true again this year. As I look at what we have to give out this year, we have.
Wait, he'll have to come back to you.
Yeah, we've got quite a number of door prizes, and I am looking right now how to open up the screen where I have them listed.
Hit the start video again. Let's turn the camera off.
You know what? We're going to attend to them at the between the next session.
That was the problem.
Yeah. All right. Our next presenter of the day is Jack Purdom, who's been a speaker at FDIM before. Let's see if we can find him.
David, you don't have to make him the host. He only has to do share screen because that you made everyone capable of doing that.
Okay. Jack, go ahead and share your screen and you can start your presentation.
All right. Am I being registered or am I still muted?
You just muted yourself now. There you go.
How's that?
Yep.
All right. Let's see if I can get this running now. Close that box. Okay. Can you see me?
See you, but I don't see your screen yet.
Okay. Let me start it. Where is it now?
Share screen down the bottom.
Share, it says share screen. Where's my presentation? Just a second. It ought to be. Watch. Let's see here. There it is. Right here. Okay. Yeah. Eric, can you see it now?
Nope.
Okay, hold on. No. Hit this again. So we have to do share screen. And can you see it now?
Nope. You got multiple monitors.
Yeah.
You got to, if you go down to what, there's some place you got to select the right monitor for
okay.
Share screen.
Jack, go down to the lower left-hand corner where you've got the mute or the audio and the video, and then click on the little caret, the up caret next to the video.
Next to the video.
And then video, you can select either the camera or the video settings should allow you to, I think should allow you to select the correct monitor.
Mirror my video. Why isn't it showing the presentation though? So is everybody enjoying the talk so far?
Well, yes.
We'll get this figured out. Why isn't it running now? That's what I don't understand. Well, we turned it off. It's so 1 and 2. So we needed to put this. Is it showing now?
No.
But what are you seeing?
You and Jack.
Okay. Video.
Okay, we do have backup. Bill, you can run the PowerPoint and have Jack narrate.
I can do that. Sorry, guys.
You know what? We're QRP folk. We just don't get bent out of shape about stuff.
I guess if we didn't have multiple monitors, it'd be a lot easier, right? There we go. Okay, just if you, I think it's F5. Yeah, there you go. Now, am I going to have to control? Can you control this, or can I control it?
You'll have to say next slide or something like
Just say
that.
next slide, and I'll
Okay.
bang the space bar.
Back up one if you can. Previous. Okay, we'll get started now real quick. I'm Jack Purdom, Whiskey 8 Tango Echo Echo. And what I want to do today is just give you an overview of what microcontrollers are and how you might interact with those. Next slide. all it is a microcontroller is nothing more than an integrated circuit chip. But the ones that most of us are going to be using are actually built on another board. Next slide. And these boards vary in cost, and you'll see that the STM 103 on the left is $3. And you'll notice that it has an awful lot of resources for the money, 128 kilobytes of flash memory, and that's where your program code goes, 20 kilobytes of data space, and a 72 megahertz clock. And I'll have a table later on that compares that with the ubiquitous Nano that everybody probably is already familiar with. The Teensy 40 is on the right. It costs considerably more in relative terms, but you'll notice the resource base is considerably deeper than it is for the STM family and much deeper than it is for the Nano. Okay, next. Why should I care? Well, I could say because I care, but that's not a good answer. I think that the reason that all of us should be interested in them to some degree is, next slide, because so many computers now are using them. And there's probably, if you look at any computer that, or I'm sorry, transceiver that's come out maybe in the last 3 years, I would venture to say that almost all of them are software-defined radios. If you're familiar with Hans's work, the QCX series, those are actually software-defined radios. They may not have the graphics that we see on the high price spread, but they're still software-defined radios. Okay, next slide. I can't even, if I had a nickel for every time someone's told me, I know you have to program them, but I don't know how to program, I would be able to have my little chalet in Switzerland and drink my malaria medicine at 5 o'clock every day. But I hear this all the time. I don't know how to program, and therefore I can't use a microcontroller. Next slide. I don't care. Go ahead, next slide. Before you got your ham radio license, how many of you knew, next, how to build a half-wave dipole? What a Cole Pitts oscillator was? Did you know Morse code? Okay. If you got a ham radio license and you can still fog a mirror, you're more than smart enough to be able to program a microcontroller. And there are so many things that you can do with programming that expand your horizon. It's a new element of this hobby that is worth investigating. So how do I learn how to start programming? Next. The first thing I think you should do, and there will be people who disagree with me, I think you need to select a chip that you want to use as a learning platform. A lot of people, just say it, a lot of people prefer to use the Raspberry Pi. Some prefer the Arduino Nano, others prefer other chips. So we'll talk more about that later on in this presentation. Once you've selected the chip, then you go about selecting the tools that you can use to program that chip. And a lot of those are free for the download. So the expense is not going to be that great. Okay, next. Collect the learning resources. There are so many tutorials online about C programming and programming in the Arduino environment that you won't have any trouble collecting the resources. Next. Online videos. YouTube has all kinds of instructables on there that you can watch. And you'll see really how simple it is. Just a few simple mouse clicks and you actually can load, compile, and change a program. Next. Online books. There are a ton of these. And some of them actually are quite good. There's a course a C course by MIT that's free for the download that is very good. Next. You can buy a real book. I happen to like this one, but I might be biased. Next. Okay, I suggest picking from this list for selecting your microcontroller. It's not exhaustive. There are a lot of other ones that you could pick, but this is what I would consider your first go at it. And also notice that the Uno is a fairly large footprint. The Nano is about the size of the first joint on your thumb. So it's quite small. And there's also one that you can buy for less than the Nano called the Pro Mini. I would not buy that. And the reason is because it does not have a USB connector on it. And the USB connector is what allows you to program from your PC and upload your program to the Nano. So I would, at least to begin with, not even consider the Pro Mini. Next. The STM32F series are inexpensive, good resource depth, and there are other things that we'll talk about that are important in making the selection. Next. The ESP32 is a very powerful chip, and a lot of people like it because it has built-in Wi-Fi and Bluetooth. So if you're interested in those particular elements of our hobby, like being able to run remotely, that might be something that you'd be very interested in. I'm not a big fan of the ESP32, and the reason is there's just too many variations of it. And there are also a bunch of pins on the ESP32 that you cannot use. And that's one reason why some of the boards will have 32 pins on it and some will have 38 pins on it. Next. The Teensy 4.0 and now there's also the 4.1 are extremely powerful microcontrollers. And they bring a lot to the table. Next. This is a pinout of the Nano. And you can see up here where this is the TX and RX signals. You do not want to use pin 0 and 1 in your programs for anything other than the serial monitor. And the reason is because that's your main communication link between your computer and the processor itself. And then most of them down here in the lower right-hand corner, most of them will use digital pin 13 to control an LED. And if you run the famous blink program, you're really controlling digital pin 13 to cause it to blink. And you can get these pinout images just by doing a search on the internet and look at the images that come up. Okay, next. This is the STM32, and this is actually the F103 series. It is very inexpensive, a lot of power, has a lot of pins. This is the one they call the blue pill. And it also has, you'll notice here that it has a serial peripheral interface pin sets. And in fact, I think there's 3 on this one. Two. And then there's also an I2C, an interconnection interface as well. And those become important when you start hanging sensors and LED displays and things like that on it. Next. This is the ESP32, and you can see up at the top in the center, that's actually the Wi-Fi and Bluetooth antenna system. The LED or the USB connectors down here, there's some support stuff. The problem is not all of these pins are available to you. This one has 30 pins brought out, and that's probably a good choice because the ones that aren't brought out, you probably shouldn't be messing around with anyway. A lot of books, including my own, detail the pins that you should stay away from. Okay, next. This is the Teensy, and the Teensy 4.0 is, again, not much bigger than your first joint of your thumb. But this thing has just a It has a mega bunch of memory, and it has flash and SRAM. I think it's got, I think it's a half a meg of space for data and 2 megs, almost 2 megs for program space. It does not have EEPROM on it like the other ones, but Paul, who designed this board, has reserved 64 kilobytes of EEPROM that he emulates in flash memory, and it works very, very well. Okay, next. Uh-oh. Wait a minute, back up. Where's all my data? Well, that sucks. Oh, man. Let me bring this up on my system here. Okay. And see if I can. Okay. I don't know how to get this over there. Go back to the slides. Yeah, I'll just describe the highlights of it. If you can put that other slide up. Yeah, that one. Okay, under the resources, I have processor bits right here. The Nano, the Arduino is 8. The Teensy, all the rest of them are 32-bit processors. So that means that the data sizes are considerably larger on everything but the Nano. Flash memory, this is the second column. You get 32K with the Nano, but you get 2 megabytes with the Teensy 4. You get anywhere from 64 to 128K with the STM series, and the ESP has 1.3 megabytes. So you go from 32 with the Nano up to, well, 2 megabytes here for the, I'm sorry, for the Teensy. The next one is SRAM. And SRAM is important. The static RAM is important because that's where all of your data go. My experience is that I run out of SRAM, memory long before I run out of flash memory. And with the Nano, you only get 1 or 2K of SRAM. You get 1 megabyte with the Teensy. You get 20K with the Blue Pill, and you get 308K with the ESP series. So you go from 2 up to as high as 1 meg of SRAM between these chips. And EEPROM, you get 1K with the Nano, and you get 64K with the other ones. Those are emulated though. And finally, the last one that I'm going to go over on this table, since you can't see it, is the processor speed. The Nano is clocked at 16 megahertz. The Teensy is clocked at 600 megahertz. You can actually even overclock that if you want to, but 600 megahertz is more than fast enough for almost anything. The Blue Pill is clocked at 72 megahertz, which is about a little over 4 times faster than the Nano. And the ESP is clocked at 240 megahertz, which is, you know, almost, well, it's over 10 times faster than the Nano. So the rest of this is in the, or the rest of these tables should be in your proceedings, and you can look at that and fill in the blanks yourself. But that might influence how you choose something, because the cost of these, the Nano is $3. The Teensy is around 20. The Blue Pill is also going to be around $3, and the ESP is going to be around $10. So you have quite a choice, and your choice is going to be influenced by what you really want to do with it. Okay, next. Okay, memory. We've talked about the 2 types. Next. Flash is where your program code resides, and that includes the bootloader. And the bootloader is nothing more than a little piece of code that is smart enough to talk with your PC. So when you're programming on your PC, you need something that allows you to shove that code from your PC into the flash memory on the microcontroller. And that's what the bootloader is responsible for. Okay, next. SRAM, this is where your data resides. And to me, this is the real bottleneck. I have, well, a couple of programs written on a Nano. I ran into flash limitations, but I almost always am pushing on the SRAM limits. Next. SRAM is divided into two places called stack and heap spaces. The heap is at the bottom and it stores all of the data that are called global and static. This includes all your functions, all of your global variables that you might have. All of that ends up in the heap space. The stack space is used for temporary variables. In other words, if you call a function and inside of that function you define some variables, they're allocated off the stack. So heap space is pretty much fixed. By the time you see anything on the screen, all of the heap space has already been dedicated. The stack space, though, is like, this is like the top of a salad plate dispenser in a restaurant. So if I call one function, it's like putting a couple of plates on the stack and it pushes it down. And if I call a function within a function, that's going to push it down some more. And if I have a lot of variables and maybe some big data arrays, that's going to push it down some more. And if I do a stupid recursive call, I can push stuff on the stack to the point where it runs into the heap space. And that's called a stack collision. If that happens, blue smoke, no, just kidding. The sad thing is that if you have a stack collision, you may or may not know about it, because this space, the heap space that's being collided with, you may have already used those variables and never use them again, and you wouldn't even know the collision happened. So the stack space, though, ebbs and flows. When I leave a function, I pop those plates off and the stack slides back up. So if I'm careful with pushing stuff onto the stack and popping it off when I'm done, and the compiler generates the code to do this for you automatically, you shouldn't have too much trouble unless you have a lot of data. Because if you have a lot of global variables, this heap space is going to grow up towards the top, and that's going to reduce your stack space. Okay, next. Clock speeds, we talked about that. Memory, flash, and SRAM, you got to look at those. The clock speed is sort of like a stoplight. The faster that thing changes, the faster you can push data through the system. So that's important for as far as the throughput of your system. Next. Pins. Most of the time you have just two pins, type of pins. Digital, and a digital pin can either be on or off. And analog. In analog depends, the values that it can assume depends on the number of bits that it uses for measuring. And the nano, for example, uses, what is a 10-bit. So you can get any value between 0 and 1023. And that can come in very, very handy for reading sensors and things like that. Whereas the digital is just on or off. You've thrown a switch or you haven't thrown a switch. Interrupt support. The nano has two external interrupts, which means that you can hang something on the nano, and if it gets triggered by some event, like it might be a rain detector, and if it starts raining, that will send a signal to the nano, and the nano will instantly quit whatever it's doing and branch to whatever routine you said should be processed when it starts raining. So an interrupt, and anybody who's raised a 2-year-old knows what an interrupt is. It's something that demands immediate attention. And the nano only supports 2 external interrupts, but you can also use the other IO pins for software interrupts. Okay, next. Interfaces, these are just ways of talking to the chip. I2C is inter connection, and SPI is serial peripheral interface. I'm going away from I2C and I'm starting to favor SPI. And the reason is because the library support for SPI has grown exponentially over the last couple of years. Next. To give you an idea of what this means is, on the left is the 2x16 LCD display you've all seen. If you have a QCX, that's the type of display that you're using. And then you have an Arduino type of board on the other side. Actually, Hans is using the raw chip, the 328. But you can see there's a whole rat's nest of wires that have to go between the Arduino and the display, and you're chewing up those pins. And if they're used for the LCD display, you can't use them for other things. Next. Now, here's the same type of display. You're looking at the backside of it using the I2C interface. And you'll note there's two power wires, and then there's a clock and data line, the green and the yellow. And you've now cut the pin count from 8 down to 2. And that frees up then the other 6 to use for whatever you may wish to use. Next. The next thing that you need to consider when you choose is the IDE, which is the Integrated Development Environment. That has all the tools that you need for writing programs. It has a text editor that allows you to enter the stuff in. It also houses the compiler that allows you to convert your C code or whatever you're programming in into binary instructions that your microcontroller can understand. And it also includes something that's called a linker. And the function of a linker is to take pre-written code that are stored in libraries and stitch them into the program that you're writing. So libraries are important because you're standing on the shoulders of people who have written things and debugged them for you, which means you don't have to write it. And that's always a good thing. Forums, all of these chips that we've talked about have their own forums that you can go to on the internet and ask questions and read their answers. I belong to all forums for all of the chips that I use, and I find them invaluable for answering questions that I can't find elsewhere. Other information resources, just look on the internet for the chip that you're interested in, and chances are you'll be able to find something. Okay, next. Cost. You can buy all of the controllers on the internet from Amazon, and you can also use eBay, Microsource, Fry's, and some of the other electronics stores, Best Buy even, will carry the more popular microcontroller chips. To my knowledge, none of them carry the Teensy. The best thing to do there is just to write directly to PJRC Systems and buy it directly from them. Cost is fairly inexpensive. Personally, I'm using eBay less. The Chinese now are getting very, very slow about shipping, and 2 to 3 week wait is very common for anything now that comes out of China. It didn't used to be that way, but it is now. Next. I've talked about the integrated development environment. Got a little ahead of myself. Next. The compiler. The only function of the compiler is to check the syntax and semantics of the language that you're using. Syntax are just the language rules that you have to follow. Semantic checks are to make sure they make sense in the context you used it. For example, if I say the dog meowed, that follows the correct rules for the language. There's a noun and a verb, but the syntax or the semantics are wrong. Dogs don't meow. The other thing is code generation, and that's important because the code generator is going to be different for all 4 chips. So when you download the Arduino IDE, you rightfully might be asking, well, how does it generate code for a totally different processor like the Teensy or the STM or the ESP? The reason is because when you go to use those other chips, you have to download and install what's called a software patch. And the purpose of that software patch is to add a new code generator for the IDE. So if you're going to use one of the non-Arduino microcontrollers, you need to download the associated patch. And they're very easy to find. If you look on the internet, do a Google search for installing the STM32, you'll find a bazillion entries for it. Okay, 2. Whoops, that doesn't matter, leave them up. The assembler converts the compiler output to binary files. The assemblers are really just mnemonics for the binary code that comes out and actually ends up being executed by the microcontroller. The linker, the purpose of a linker is to take those pre-written chunks of code that other people have written and stitch them into your code. And the depth of those libraries is a huge factor in how productive you can be in writing your own programs. Next. Where do you start? You know, if you got this 4-ton elephant in the room, how do you start to eat it? Well, you do it one bite at a time. And to me, any program in the world, I don't care how complicated it is or what it is, can be reduced to 5 program steps. Number 1, initialization. This sets the environment in which the program is going to run. If you're doing a database program, you're going to have to open the database and establish a link to it. If you're using a fiber optic network, you probably have to set some kind of a port for the fiber optic. All of these are initialization things that you have to do before you even show anything to the user. There are background startup tasks that you have to take care of first. Okay, next. Once you've got things ready to go and you pop something up on the screen, you're probably going to ask the user or one of those sensors or a database connection, something to input some data. And obviously you need to verify that data to make sure that it's in a form that is truly usable. Okay, next. Then you process the data and you use a plan called an algorithm to process the inputs. The whole purpose of a computer program, if you think about it, is taking input data in one form, crunching on it, and next, output it to some other form. And that processed data could go somewhere else, or you might use it in your own program. You might save it to a disk file, whatever. The steps 2, 3, and 4 just take data in one form, chew on it for a while, and spit it out in another form. Next. And then the last step is termination. And termination means more than just removing power. What you really should do is, if in the initialization step you opened a port, you should give that port back to the op system when you're done. If you opened a fiber optic connection, release the handle to it so you gracefully end the program. Now, microcontrollers are different because they are not designed to terminate. Most microcontroller programs are designed to run forever. So if you have a stoplight in a traffic pattern being run by a microcontroller, it doesn't do a whole lot of good to shut it down at 5 o'clock. It's meant to be there regardless. So termination in a microcontroller program is rare. Next. It normally only terminates when power is totally removed, or you perform a reset, and most of the microcontrollers have a reset button on them, or you had a component failure. In most of the other programs, it's designed to run forever. Next. Okay, this is a Blink program. This is probably the most it's like Hello World in C. It's designed to make sure, well, I think it's designed to make sure that you install the IDE correctly. And it has two functions in it. Setup, which I've highlighted in yellow, and that is the initialization step. It is setting the environment to be used for the Blink program to run. And to do that, it says, okay, I want to use LED pin 13. I want to use pin 13, and I want to use it as an output pin. If you recall, when I showed the pin out of the Nano, I said pin 13 was the LED. Well, that's exactly what we're doing here. We're telling the compiler, okay, I'm going to use the LED pin and I'm going to use it for output. Once, and that's the only setup that I'm doing here. The initialization is very simple here. Then I go down to loop, and loop is something that just runs forever. Once you get into loop, unless there's a power removal or reset or a failure, this guy runs forever. And if you look real closely, you can see the cows coming home down here at the bottom. Anyway, what we're doing here is we're doing a digital write to pin 13 and we're setting it to high. So in essence, we're turning that onboard LED on. Then we call a library routine that somebody's written for us, and we're gonna delay the processor for 1,000 microseconds. So we're gonna wait for a second. This L I put in, a lot of people don't put it in, but I put it in because that 1,000 is a long data type. It's not a normal int, it's a long. So I just put that in there to kind of jog someone's memory if they're reading it. After that 1 second delay, then I do a digital write to the same pin, but this time I'm going to turn that pin low. So obviously what I'm doing is I'm turning off the LED. And then I do another delay for 1 second. Once I get to the bottom here, then, because this is a loop, it goes back up to the first statement in the loop and it executes it again. So if you look at the 4 statements here, all I'm doing is turning on and off the onboard LED once a second. And that's all that the Blink program does. Okay, now, when you start to get into more complex programs, setup is going to get considerably more extensive, and loop will also get more extensive. But I think what you're going to find is buried in loop will be calls to input the data, step 2. You'll have calls to process the data, step 3. And then you'll have calls to output the data, step 4. And then you repeat it again. So we don't hit that termination step. We just continue to spin around in here. Okay, next. Oh, crap. I had 2 more slides. Let me go down to the bottom here and see if I've got them on this. It doesn't look like this has it either. I don't think I gave the latest to Al. But anyway, all it did was a summary. And I was trying to point out that the cost of getting started in doing something with a microcontroller is probably under $5. If you go out and buy a Nano and have a USB cable that can run from your PC to the Nano, it uses the voltage from the USB connector, so you don't even have to buy a power supply. And that would be enough to get started. And once you get started, I've got you, because you'll find that this is a whole new avenue in your hobby that I think affords you a lot of different options in terms of things that you want to do. And you can do them in software rather than hardware, which is the big advantage of software-defined radios. It's very easy to change filters, to change other elements of the radio without having to change a hardware circuit. Okay, I finished 5 minutes early.
Hey, thanks, Jack.
Any questions? Perfect.
Okay, we do have questions. Can you see them in the question and answer window? I can read them for you if you wish.
Why don't we do that? Because I don't see it.
All right, gladly. From Jawar Bami, comments: by not recommending ESP, you take away the wholesomeness, and BT dimensions, nanos, and other Arduinos are too long in the tooth to recommend or consider. What about RPI Pico? All of them offer Arduino API, so from a programming point of view, there's no big difference. You can get more familiar. You can make sophisticated or use libraries. Libraries are the key for making choices, and people are hesitant about programming, can take comfort in that libraries abstract a lot of the complexity.
It's exactly right. He mentioned the Raspberry Pi Pico. That just came out. I think it's less than a month ago. It's a relatively new product from the Raspberry Pi people, and it has a lot going for it. The whole Raspberry Pi thing is really different than what I'm talking about here. The Raspberry Pi has its own operating system. It has built-in high definition television outputs. It is a computer, a true computer, whereas microcontrollers don't have a native operating system, and they're not designed to do the same things that the Raspberry Pi can do. The Pico is, I think they've got it complete now, that the IDE now supports the Raspberry Pi Pico, and it's not expensive. I think it's like $5. They're fairly inexpensive. I have not played with one. I went to try and buy one at Micro Center here in Cincinnati, and they were sold out. So I have no experience with them, but I know they're very powerful and fairly inexpensive. And you are going to see a ton of library support coming out for them, I would imagine, very, very quickly.
Okay, very good. Neil Ormos asks for you to comment on EMI EMC considerations.
You know, Al and I are working on a software-defined transceiver, an SDT, and we have those considerations to a lesser extent because of crosstalk occurring with inside the chassis. We're not experiencing much, and to be honest with you, we haven't had to worry about it much. So it depends on what you're trying to do as to whether those become issues or not. You know, I have no experience with it, so I'd be uncomfortable trying to give him a good answer.
Okay.
I gave him a bad answer.
Good enough. From Stan Grigsby, he needs to work with a sensor that's more than 5 meters from the processor. I2C seems limited to 1 meter or 2. How can you extend this?
Is there a possible, well, ask yourself this, could you use a Wi-Fi link? Because the ESP does have a Wi-Fi link, and I know that that's been tested to 100 feet. So maybe that's the way to go. SPI, I've run to 20 feet. So give an SPI interface a shot, give it a try. It's costs you nothing to do it virtually. They're just pin connections on the board. So see if that might work.
Very good. From SV1ONW, he asks, do you think that the Raspberry Pi Pico will be the new player in the market at the price point? Yes.
And the reason is just because there's just under a bazillion people using the Raspberry Pi. The thing that bothers me a little is, some of you know, I've been using C now for almost 40 years. And it's one of those old horse things, new tricks, dog. I don't want most of the work being done with the Raspberry Pis being done with Python, which is very C-like, but it's different. And everyone who's played with Python as a language really seems to like it, but I have no expertise in it. And, you know, I don't know how much time I have left, you know, how much sand in the hourglass. So I probably am not going to invest the time it takes to become proficient at it, but I would expect it to be very popular.
Outstanding.
Well, that's a good thing too. David, because that means that library support will come up or ramp up very, very quickly.
Good point. From Don WB0ISG, he says, great presentation. Once you have chosen a controller, say the Arduino, and you outgrow it, how hard is it to step up to another controller like the STM32F103?
Almost all of the libraries, most of the code that you're going to be using is in the form of libraries. And the core libraries are identical across processors. In other words, there's an object called the serial object that you'll use for debugging in the IDE. That is uniform across all of the processors. Things like delay, pin mode that we saw in the Blink program, those are all the same across processors. What will be changing are some of the things under the hood. Instead of talking like on the ESP, instead of talking to pin 13 for the LED, they use pin 2. Why, I don't know. Everyone else uses pin 13, but they don't. But that abstract, there's a hardware abstraction layer in there where all of those kinds of dirty details are hidden from you. So I think moving to a different processor is not that much, you're not going to experience much difficulty at all.
Okay, good. Bob K2KI asks, he bought a Raspberry Pi Vanilla and never broke the seal on the box. Is it worth using it, or should he can it and get something newer?
Ask yourself, what do I want to do? The Raspberry Pi is a very, very powerful processor, but it is a computer. And if you're going to hang sensors on it, or you're going to try and do experiments with it, the Raspberry Pi really doesn't have a lot of I/O pins available for you to play with. So if that's the route you're going to go down, take it back, get a return, and pick up one of the other processors and just start playing with that. The other good thing is if you buy a Nano for $3, I mean, you can't even get a morning latte for that. So your cost of investing it isn't like the $40 that you paid for the Raspberry Pi. $3 for a Nano, and you can really start doing some kind of fun stuff. And there are a ton of sample programs that come with the IDE that you can experiment with as well.
Very good. From Joe Cornell, what's your opinion on using PICs?
PIC is an old processor. It's been around. In fact, it's older than the Arduino family are. And there's still a lot of code being written for the PIC processor. I've never done anything with the PIC. And I can't give you a good reason why. I think the reason is because the PIC uses a different IDE. And once you learn an IDE, you know, it's that dog trick thing again. So I just stick with what I know. But PICs are around and they'll continue. They're probably like the cockroach. They'll be around forever.
Yeah, definitely. From Brian Bowling, have you tried the Arduino 2.0 beta? Did you try the debug?
I have. I know Brian, he lives just down the road from me here. And I have tried the beta. The thing that disappoints me right now is that the debugger only works with some of the high-end, what used to be Atmel processors. Now it's, what is it, something micro. But my understanding is that they are going to eventually expand the base of that debugger so that it handles all of the processors, not only the Nano and its family, but also the other ones that have the software patch. And in fact, my guess is that the STM, ESP, and Teensy people are working right now to get their debugger core up and running with the new 2.0 beta.
Okay. Our final question this morning from Marty NR3Z. Please comment on using the Pi for MQTT server and other sensors.
I haven't done anything with using the Pi as a server. If you buy the ESP, I think one of the sample programs that comes with it is a client server application. So that's already written for you if you buy an ESP. And there are a lot of articles written on setting up servers using any one of the processors. So I don't think that would be a very, very difficult project to do. And the Raspberry Pi has more than enough horsepower to do it. I know that I think it's Pete Giuliano out in California has a Raspberry Pi doing all kinds of different things. And I think one of them is a home-based server.
All right, thank you very much, Jack. We got a lot of really good questions. I think this was a really good presentation.
I will be up tonight as well.
Thank you very much.
Okay. See you guys.
All right. Okay. I found my list of door prizes. So we're going to proceed on that. We have quite a generous list of donations, starting from Ether Kits, which is the concern of Jason Mildrum, NT7S. Jason has been well known in the QRP world for a long, long time. And he has generously donated some of his microcontroller boards, the Empyrean Alpha. We have a number of those, and they have been drawn and will be going to Stan Nafziger, KF4BY, Tom Christian, AB7WT, Dale Jensen, AA7OY, Sam Rowe, KG9NG, Mark Friedman, WB8BCU. We've also got donation of an RX-TX transceiver from 5 Dash. And the winner of that is Mark Smith, N6MTS. And from NM0S Electronics, never heard of that guy before, Richard Nolet is the winner of a Discovery Crystal Radio. That's the new kit that has just come out in the past couple of weeks. From Mike, or for Mike Stillwell, AC0Y, he wins a QRP ohmmeter. Robert Andrews, W3ARA, wins a Cricket 80 transceiver. Aaron Johnson, WD7 VDG, wins an NS40 minimalist transmitter. So congratulations to all you guys. These door prizes will be mailed out to you, and you should get them in the next few weeks. So let's look at the time. We've still got a few minutes. So this will be a time to take a break, stand up, stretch your legs, and when we resume at the top of the hour, 11 o'clock Iowa Daylight Time, we'll have Dino Pappas. Okay, everyone, welcome back. This is FDIM 2021. We're a quarter of the way through our presentations of the day, and I'm delighted to see how well they've been going. Next on our agenda this morning is Dino Pappas, KL0S. Dino and I actually have some history together. We were both members of the Williamsburg, Virginia Amateur Radio Club in the time that I lived there. And I understand from Dino that there's been some substantial growth in the club since I left.
Yeah, there has been a
So,
bit. COVID is like a lot of clubs, has probably added to their roles.
well, certainly. What's your presentation on today?
First of all, I want to say that Jack is a hard act to follow, so I hope folks aren't falling asleep. My name is Dino Pappas, KL0S. I've been a ham for about 51 years. Pay no attention to the big linear amplifier there. I am interested in QRP, but I will use QRO when required. You may have seen some of my articles in QST and On the Air and DX Engineering's On All Bands blogs. So I want to say thank you for the opportunity to address you here today. I'm a test equipment junkie. You can probably see that on my QRZ page. There's some pictures there of my my workbench. I've given this type of presentation before. I was honored to do a couple of presentations at Dayton Hamvention over the years. This is a pre-recorded presentation, but I will be watching the Q&A, and then I can answer questions at the end as well. So without further ado, what I'm going to talk about today is using inexpensive test equipment at your bench. And we'll tell you the reasons why and go over some of the stuff. So let's go ahead and get started. If you'll allow me to share my screen and come down here. Greetings, everyone there at 4 days in May, or virtually 4 days in May. This is Dino Pappas, KL0S, and I'm speaking to you from Williamsburg, Virginia. I was looking forward to making this presentation last year, but COVID-19, of course, got in the way. And I was invited to make this pitch virtually, and we'll give it a try, but we really look forward to getting back together again in 2022, hopefully with the Dayton Hamvention in 4 days in May. Test equipment has had a long history of being big, heavy, and expensive. Over the past decade, advances in miniaturization and economies of scale have reduced the size and cost of a slew of instruments to those affordable by many amateur radio operators. The last few years have brought us new and more advanced antenna, spectrum, and vector network analyzers that have exponentially improved the RF measurement capabilities that we have. Function and RF signal generators, frequency counters, component testers, and many other instruments are now readily available and relatively inexpensive. So let's take a look at how the average ham can assemble and integrate a suite of these inexpensive instruments and create a test bench capable of both maintaining their own stations, but a space where serious design and measurement projects can still be undertaken. First, I want to thank Steve Dick, K1RF, for his 2017 presentation describing low-cost test equipment that you can buy on eBay. His ideas mirrored my own, as I have made several similar test equipment presentations at ham clubs and at the Dayton Hamvention. And you can easily find Steve's presentation on the web as well. So let's get started. It's probably not a surprise to you that the old adage, you get what you pay for, usually applies. But with many of these new inexpensive meters and testers, the bang for the buck you can get can be surprising. Lots of Google searches provide many reviews and feedback on these devices, and at some of the rock bottom prices, you sometimes simply can't go wrong. And more importantly, simply because test equipment is reasonably priced does not mean that you can't make useful quality measurements at your bench. Having said that, sometimes it may be beneficial to go to the other end of the spectrum and follow the axiom, buy nice, not twice. Does your workbench or shop need to resemble a NASA laboratory or a professional engineering lab? Of course not. We all started out small with the test equipment and component stocks that we could assemble and afford. Over time, we gathered additional equipment and junk box material to suit our designing, building, and repairing activities. It's not so much what's on your bench, but rather what you do with it that is important. But before we go on, I'd like to offer a couple of good references you may want to consider. First, the book Build Your Own Electronics Workshop, and a second volume, Test Equipment for the Radio Amateur, are great references for general workbench building and outfitting guidance. They're both a few years old, so likely won't cover some of the newer instruments we'll discuss here, but are still great overviews for those putting together their first ham radio workbench or looking for ideas on how to improve their present setup. Don't let pictures of huge masses of test gear scare you off, though. Well, maybe this is what killed off that transistor in the middle of all of that stuff. So, why do we need test equipment to begin with? Sometimes that's not necessarily an easy question to answer, but let me take a swing at it. The reason the FCC allows the amateur service to build and operate our own high-powered radios, assemble a station capable of around the world and through space communications, is to encourage us to be prepared to accomplish our emergency communications mission. Other radio services have operators who simply turn a radio on, operate it in a channelized frequency mode, key and speak into a microphone or type text into a mobile terminal without having to know how the equipment works or is assembled into a complete station, reaching from the power source to radio and data equipment to an antenna and beyond. So amateurs are required to take an exam demonstrating their baseline knowledge to operate and maintain equipment that has the potential to interfere with other government and public safety radio systems. So it takes at least some modicum of test gear to properly maintain and operate our equipment so that it functions legally, safely, and does not interfere with other amateurs or services. What things do we need to be able to measure? Voltage, current, resistances, polarity, power, impedances, and many more. We also need to be able to characterize and measure different types of signals, including frequencies and harmonics and various forms of modulation. Here are the different types of test equipment we'll discuss. What I'll show you is for each category will be examples of expensive commercial equipment, followed by much less expensive substitute instruments that a typical technically oriented ham might have at his or her workbench. Let's get started with probably the piece of test gear that you'll find most common and most useful on your bench, the digital multimeter or DMM. Here you can see a Rigel 6.5-digit multimeter that probably is 3 digits more than you need for most measurements, and it's going to cost you north of $500. The Uni-T DMM you see here will set you back around $125, but it is a nice instrument to use both at the bench and has the added capability to be used portable away from the workbench. Let me put my first plug in for older test equipment that is both relatively inexpensive and remain valuable tools at the bench. The Heathkit vacuum tube voltmeter, or VTVM, still uses those funny looking things called tubes, and yes, it is an analog meter, but is useful for a couple of different reasons. It's inexpensive, easy to fix yourself, provides a high impedance input that won't load down the circuit you're intruding into, and the bonus of an analog meter is that it is a much better tool for adjusting circuits where a relative indication of a peak or minimum value can easily be seen. That's really hard to do with a DMM. Although some DMMs try to get around that limitation by displaying a bar graph, but it's still not as good as an analog meter in that regard. A handheld digital multimeter can do double duty, useful both as a bench and a portable instrument. As with the bench style meters, these range in both price and capabilities. The Dave Jones EEV blog series of meters are an excellent value for the things that they can measure. An inexpensive meter is a good tool to keep in your vehicle. Just don't forget to keep track of the batteries to avoid the embarrassing situation of it being out of operation just when you need it. As you can see here, you can find all sorts of really cheap meters. You might say if it's too good to be true, it probably is too good to be true with these meters. But having said that, for that price, you almost can't afford not to have one in your car, plane, or backpack when you attend a hamfest, where simple functionality or resistance checks are what's really important. Let's turn our attention to component analyzers, those that can measure and characterize the operation of semiconductors, resistors, capacitors, and others. Some of you may be familiar with them, and the Huntron brand of instruments depicted here are expensive. Is there something that can perform the same function for less money? Here's a component analyzer that comes very close to mimicking that of a Huntron, and you may still be able to find one on eHam or eBay or maybe at a local hamfest. I still have this Heathkit component tester that I built many, many moons ago, and it still works well on my workbench. In addition to the old Heathkit, here's a suite of component analyzers I use at my bench from the Peak company in the United Kingdom. There's a combined capacitor and equivalent series resistance, or ESR meter, which is very helpful when checking large value electrolytic capacitors, a general semiconductor tester that will check the operation of and tell you which lead of a device is which, and one specifically for checking Zener diodes. And then finally, there's a combined LCR meter as well. Here's a combination inductance, capacitance, and resistance meter. You'll see a lot of cheap knockoffs for these units, so buyer beware. On this unit, the tweezer probe allows you to check surface mount devices easily. Finally, there are a slew of really inexpensive component testers, especially at sites like eBay, Banggood, and others. And surprisingly, they do a good job even at ridiculously low prices. Okay, let's now take a look at frequency counters for both audio and RF signals. Depending on how much resolution, in other words, the number of digits you can observe, and the accuracy you want will determine the type of counter you'll want. Counters depend on the accuracy of their time base, usually some kind of crystal-based source. Better counters, like this HP counter, encase that oscillator in a heated container to maintain the temperature coefficient to keep the crystal at the same frequency, and thus the accuracy of the signal you're measuring. Up until about 20 years ago, most hams would calibrate their radios and counters by comparing their time base, usually 10 megahertz, with the signal from the National Bureau of Standards radio station WWV at Fort Collins, Colorado, or its sister station in Hawaii. Other methods to calibrate counters included matching the frequency observed with the highly accurate color burst signal sent along with over-the-air analog color TV signals that, of course, are no longer available with the changeover to all digital TV signals. Another method of providing an accurate reference involves using GPS-disciplined oscillators that were widely used in the cell telephone industry. When those units were made surplus, many hams gladly put them into use at their benches to be able to make highly accurate measurements, often good to 1 part in 10 to the minus 11th. Those units were then replaced in cell service by rubidium-based oscillators that operated independent of any other source. Hams were the glad recipients of these units when they too became available on the surplus market. The unit in the upper left corner is the Z3801A GPS disciplined oscillator. That's the first one that I had on my bench, and I still have it there, although I don't use it because it requires quite a bit of power to just be on all of the time. You have to leave it on 24/7 for it to be functioning correctly. So I replaced its functionality with what you see on the right-hand side. I built a rubidium frequency standard. And that one you can leave off until you need it. You flip the switch on, and once the red light goes out and the green light comes on telling you that the reference is locked, then any piece of test equipment on your bench that you're distributing the 10 megahertz reference out to is ready to make highly accurate measurements. Here's an example of a counter that's still popular. The Heathkit counter has both a temperature compensated crystal time base and the ability to accept an external 10 megahertz reference, and will measure up to about 600 megahertz. I built this unit many, many years ago, and you can get them at a ham fest for less than $100. They're a great unit, and although it's rated to only count to 500 megahertz, they usually will go up to at least 600. Today on eBay and elsewhere, you can find frequency counters for anywhere between $10 and $100. So the Chinese ham BG7 TBL has designed a series of inexpensive RF equipment that we'll see in other categories. If only a quick general indication of frequency is required, these portable counters are great to have in addition to a bench unit. Function generators will generate sine, square, and triangle waves, all of which are useful at both audio and radio frequencies. Some are capable of creating many pre-recorded signals ranging from heartbeats to random noise. Others can accept a signal that you design yourself to meet your own requirements. The Rigol generator shown here can generate sine waves up to 160 megahertz and square and triangle waves at lower frequencies. A key difference between a function generator providing an RF signal and a dedicated RF signal generator unit is that the levels available may not be low enough for receiver testing, but you can always use an external attenuator to drop those signals down low enough to be useful in that role. Here's an example of an inexpensive function generator, and you can see that as the price goes down, there's a corresponding lowering of the highest frequency that can be generated. Even less expensive units are available, and again, the frequency range goes down, but they can still be useful for audio and slow-speed digital signals. Here's an example from eBay for less than $6. Quality? I don't know, but if you just need a basic signal to provide a frequency out in the field, for example, somewhere just testing something simply, these can be very useful as well. Now, dedicated RF signal generators are really useful for all sorts of radio equipment testing and repair. This unit from Rigol can generate signals up to 3 gigahertz with a corresponding price. Again, we can see now very capable RF signal generators at attractive prices. As we said, some of these units, especially the one from BG7 TBL, can accept a 10 megahertz external time base. But don't forget older analog style RF generators that, although they can't accept external references, are perfectly suited for boat anchor radio and equipment work where tight frequency and level tolerances really aren't required. The ability to measure power is another important function to keep our stations functioning properly. Low power measurements are important as well in design and repair of circuits well before a transmitter's final amplifier stage and deep inside a receiver's chain of oscillators, amplifiers, and mixers. High-priced power meters usually require a dedicated cable that attaches to different sensors that are power and frequency dependent. Even older surplus HP power meters can be had for $100 or less, but the cost of the required cable and sensor can often be 5 to 10 times that price. Here's an example of an inexpensive combination power meter and dummy load that is good to above 2 gigahertz, and it's hard to believe that it will actually dissipate 50 watts of power. Surprisingly, it actually will, but just don't keep that kind of power applied too long. Again, this inexpensive unit is actually pretty versatile, as my unit will measure all the way up to 2.6 gigahertz and as low as 1 kilohertz, and will accept any power from 0.1 watts to 50 watts. And yes, again, that surprised me too. Here's an even cheaper example of a PCB-based circuit you can get on eBay that will measure RF signals from minus 75 dBm to plus 16 dBm, and from 1 to 600 megahertz, and some units even greater. I built the power measuring circuit into my own enclosure. It will translate RF signal levels to a DC voltage, and you can see from the graph that in between minus 74 dBm and plus 18 dBm, the response is very linear, and that linear DC voltage you can measure and then correlate to its appropriate power value. Not bad for about 20 bucks. Let's turn our attention now to oscilloscopes. Besides the digital multimeter, the oscilloscope is one of the handiest tools you can have at the bench. The scope is virtually a TV set that lets you examine signals throughout your shack. Analog scopes like this venerable Tektronix 465 are popular, and even though they're getting long in the tooth, if you don't abuse it, you can expect it to be a good unit. Analog scopes lack the modern features of automatic measurements and others, but that's a small price to pay for a small price. Surprisingly, an analog scope in some cases can display a signal better than a modern digital scope. As scopes matured, the digital age brought more measurement capabilities to the table. This Tech 2440 scope, although still using a CRT display, allows you to take a digital snapshot of signals that you can then make further measurements of. By the way, tech scopes of this vintage often had a signal available at the rear panel, which is an amplified representation of one of the input channels. This allows you to attach a counter, for example, and measure the frequency of the signal that your counter would not necessarily have the sensitivity to measure directly. Fast forward now to the miracle of digital-based inexpensive scopes. The Rigol scope you see here has 4 separate channels and a 50 megahertz bandwidth. You should know that this bandwidth frequency specification relates to the point where the scope's response is reduced by 3 dB. That means your scope may in fact suitably measure signals above that frequency. And if all you're looking for is the shape or quality of the signal that the reduced display will give you is still useful. The math functions, including the fast Fourier transform, allow you to use many of these new scopes to function as a basic spectrum analyzer as well. And today we're finding more and more computer-driven test equipment that remove the need for the box to provide the unit's display. This makes them much more portable and allows you to use complex computer software to perform a multitude of measurements, reducing the need for those capabilities to be built into the scope's hardware. Of course, there are less expensive units. The mini oscilloscope you see here puts a decent portable scope in your shirt pocket, ready for use anywhere. There are even units at the $25 level, but they're very limited. If all you're measuring is a low audio frequency or very slow digital signal, it may very well be sufficient. Spectrum analyzers are tools that engineers and technicians drooled over back in the day. Unlike the oscilloscope that operates in the time domain, spectrum analyzers display frequency versus amplitude. And even back then, many companies even limited those who could actually put their hands on those instruments and use them. Several manufacturers compete in this arena, and here you see a Roden Schwartz high-end unit. But don't get discouraged by the cost just yet. And it wasn't long ago that consumer grade and priced spectrum analyzers came onto the scene. Here's a Rigol analyzer that will measure signals up to 1.5 gigahertz and also has a built-in tracking generator that's useful for testing filters and even tuning your repeater's duplexer system. Look to spend about a kilobuck for one of these, but I'm sure that you won't regret it. I didn't. In just the past couple of years, another leap has been made, reducing the price of basic units like the tiny spectrum analyzer shown here. For about $60, you can have a shirt pocket size analyzer that will display signals up to almost 1 gigahertz. Although the tiny SA may not have the measurement speed or dynamic range of the kilobuck boxes, it's still a great basic instrument and can make good measurements. We'll also see the tiny SA's cousin in the realm of vector network analyzers. You're probably familiar with the large number of software-defined radios, or SDR. Many inexpensive SDR dongles can be used with software to view and provide at least relative signal comparisons. There are also several new SDR receivers that include a built-in display, as you see here with the Russian-designed Malahit portable. In a pinch, these receivers can function as a limited spectrum analyzer and are great for hunting unwanted RF noise sources like power line noise. Wes Hayward, W7ZOI, and Terry White, K7TAU, described a Homebrew spectrum analyzer way back in the August 1998 issue of QST. Like other units of the time period, their analyzer used an oscilloscope working in the XY mode to display the spectrum. Still a viable option for those who enjoy rolling their own. Like their cousin, the spectrum analyzer, the Vector Network Analyzer, or VNA, has been a way too expensive piece of equipment for us up until just recently. Even surplus units still bring top dollar. VNAs can provide both scalar and phase information across a device under test. The dam began to break several years ago with the introduction of Tom Bayer's DG8 SAQ's VNWA, now in its third iteration. Others in this category still bring a cost in the $400 to $500 range, and they are quality instruments and enjoy large followings. But the world moves on, and a Chinese ham was one of the first to design and market the Nano VNA that is now also in several variants. Costing only about $60, the unit provides several functions, including standing wave ratio, Smith charts, return loss, and 2-port measurements. These short pocket size antenna and more analyzers are great instruments as long as you understand the limitations they operate under. For the average ham, these limitations really are not significant. Although the Nano VNA and the Tiny SA are available from a wide variety of sellers across the spectrum, no pun intended, we've found here in our club that R&L Electronics have them both at a lower cost and provide great customer service that you may not find with other sellers. We shouldn't discount our ability to roll our own basic test equipment. We may not do the original design, but there are many project articles available to replicate. Here are some that I've built over the years that are nice to have when a specialized need comes along. The one in the upper right-hand corner is a crystal tester, a small RF generator directly below it that'll go from 3.4 to 31 megahertz, and a RF phase meter on the left that is useful as well. And here is just a small list of suppliers, many of which you're probably already familiar with, who market inexpensive test gear and components. Okay, that was a real whirlwind tour of inexpensive test equipment that you can use to outfit your own RF test bench. There are many more, including power supplies, electronic loads, digital logic testers, and others. I would like to put in a recommendation for organizing the more technically minded members of your local club into a builders group. Many clubs have them, but they're not just for the experienced ham. They should be the breeding ground for future technically oriented hams, both male and female. Our club has several YLs who jump right in and warm up their own soldering irons. It's been a real treat to be able to share this time with you today. I really appreciate the invitation, and hopefully this has been of some use to you. And now I'm prepared for any of your questions. Thanks for your attention.
Very good, Dino. Thanks for that.
Let's see if we have any questions in the Q&A. See, Dennis, G6YBC talks about building your own spectrum analyzer, and info being in the book Test Equipment for the Radio Amateur version 2, which is, I believe, is the one that I displayed up front. I do want to greet, hopefully he's out there. I saw his name on the registration list, Mike Doty, W0MNE, good buddy from the past, who actually was the impetus for our club's builders group from many years ago. We started it in 2014. There was an article about it in February 2015, I think, issue of QST, and it's proved to be a real boon to our club. Let's see, do we have any other questions?
Yeah.
Oh, I'm sorry. Shoot, I didn't scroll down. I'm sorry. Logic analyzers for use with nanos. Yeah, there's obviously the basic ones that Radio Shack used to put out, the handheld ones. There's several versions. I mean, there's some original HP type or Tektronix. Tektronix and Sony made one that I've got back in a dark, dingy closet somewhere. There's several small logic analyzers that you can hook to your computer. Not sure about their capabilities. I'm trying to remember off the top of my head the name of the one that I even have. It's over in my tool cabinet there. Yeah, there are several of them out there, and I just didn't cover them in detail, David, who asked the question. What will I be working on when I suddenly discover the need for more digits on my digital multimeter? That's a good question. Sometimes working with a voltage controlled oscillator might need a few digits past 3.5 or something like that. There are commercial standards available for resistance, current, and voltage that you can get for relatively inexpensively to calibrate your meter if you need it. Let's see. Thanks for the presentation. What would the minimum spec on oscilloscopes for homebrewing your own transceivers, for instance, the RX, TX in the most recent QRP quarterly, which I did get the other day in the mail. I haven't read it yet. You can get an inexpensive Rigel scope these days, and Siglent and some of the other manufacturers as well. Probably, if I had to guess, if money is an issue, for about $300, you can get a 2-channel oscilloscope that is at least 100 megahertz and maybe even more. And it's been a while since I looked at them, but if you're talking at about the $500 and less range, a 100, 200, maybe 250 oscilloscope would be more than sufficient for anything you were going to build, I think, in that room. Tube testers, yep. If you still work with tubes, I've got an IG21, I think, over there on the other side of the room. Every once in a while, somebody comes up with a project or something, a boat anchor they're trying to restore and needs a tube tested, and they're available at Hamfests and on eBay. If you just Google for tube tester, you'll find probably links to eHam for sale lists and eBay, of course. Usually it's, do you really need one? If somebody in your neighborhood has one, that's usually the best thing to do. I have one, and there's at least one more here in town, at least one, maybe two. So if anybody needs a tube tested, we're usually pretty good for that. What would you advise as a project for a station monitor? That's a good question. If you're talking about, Steve, if you're talking about the old Heathkit vintage SB610 or 620 station monitor, or the Kenwood SM220, there's a couple of articles, I think, that have been in QST or maybe CQ that talk about that. I'm not sure if there is a commercial version. Oh, wait a minute. Well, don't get old, whatever you do, it sucks. There is a company, and I'll answer the question. I'll get you the answer to that later. But there is a company that has some units that you can buy that will function as a station monitor. Did I build NorCal QRP's FCC1 frequency count? I did, and it's not a bad little frequency counter. It's too bad they're not available anymore. There were 2 kits, as I recall. I think I've got both of them, the FCC1 and the FCC2. As I recall, I don't believe it will accept an external reference, though, but if you just need a general indication of whether you're in the 40-meter band or not, or you're somewhere around 7.039 or 7.040, a cheap frequency counter is probably close enough for government work. Let's see. What about the analog Discovery 2 from Digilant with the ham discount? I'm not familiar with that. I think that might be one of the multi capable units. There's a couple of them out there that provide basically a test equipment suite in a box. I don't have any experience with it, but I would be interested in hearing from someone who does. And Steve says, yeah, he wants to convert an oscilloscope. I think if I'll get the answer to you, the company, it's RF something. They build quite a few units like that. They also build some loop antennas for magnetic loop antennas. What is reliable info on test equipment, specific brands, models available? How do you avoid buying some device and then finding out 3 weeks later that there was some forum somewhere that explained all the problems with it? That's probably a question that applies across the spectrum. I would point you to Dave Jones' EEV blog. And if you sign up there, you can, I don't even know if you have to sign up. I think you can search the database of questions in there. There's been people who have reviewed things. I'll give you a good example of that. Rygal's digital power supply, the DP832 and the 832A, which is the one I have, had a real problem with one of the voltage regulators being not adequately heat sunk, and Rygal took the bait and they fixed it. So I would, someone said in the chat as well, I would point you to the EEV blog. What's the difference between a function generator and an arbitrary function generator? Well, they're actually can be one in the same. The basic function generator will give you the basics like triangle, sine waves, square waves, and that type thing. The more expensive ones will give you pre-recorded signals like a heartbeat or random noise and that type thing. If you go up a little bit above that, you can actually design in software an arbitrary signal and then simply upload that signal to the generator, and then it'll output it for you. Is more info available about the rubidium frequency standard you built? If you go to eBay and just Google or search for rubidium standard or rubidium frequency standard or frequency standard, the units come from China. They came out of cell sites after the GPSDOs were taken out, and you give it some voltage, and it'll work great. And the nice thing about it, as I said in the presentation, is you don't have to leave it on all the time. The difference between GPSDOs and rubidium standards is one is better at short-term accuracy and one is better at long-term accuracy, but you're talking about measurements with an accuracy down to potentially 10 to the minus 11th parts. So, are you really on 146.52? How many zeros do you need out to the side to know that you're on frequency? Neil, if you want some more information about the one that I built, send me a note at KL0S@ARRL.net, Kilo Lima 0 Sierra @ARRL.net, and I'll send you some pictures and notes that I had for that. And another lead to the EEV blog forums. They've got great discussions in there. And let's see.
Asher's got a question in the chat. He says, what do you recommend as a minimal set of test instruments that a home brewer should have?
Well, the first thing is going to be the digital multimeter. The second thing is probably going to be a bench power supply that will give you 5 volts for working with TTL logic. Nowadays, you also need a power supply that will give you 3.3 volts with the lower powered microprocessors. And then usually you get 2 more channels that'll give you something like 0 to 20 volts. And they will actually, you can have them track. Heathkit's got a great supply that I've been using for, gosh, I don't know, 40, 45 years now, that I think I had to replace a diode or a transistor once in it and all that time. So a power supply, an oscilloscope, and a person with a good brain and a DMM can do a lot that a less experienced person can do with a really expensive spectrum analyzer. So those are probably the basics. The two books that I mentioned are probably good references. What do you think the best oscilloscope is for the beginner? Siglent, Rigol, Handtech, they all make good scopes. It's almost like Chevy, Ford, Chrysler. Which one looks the best to you? There are some technical aspects to the scopes that make a difference, and I would do a little bit of Googling, because when you get into the digital realm, the depth of the memory has an impact on things. If you're looking for just a basic scope, I'd go with an older analog scope to begin with until you learn how to use it. It's not going to have one of those buttons that says auto on it like the modern scopes do, which forces you then to actually learn how to adjust the triggering, adjust the voltage levels and the horizontal controls and that type of thing. So I'd start with a cheap analog scope, to tell you the truth. Let's see, what components need to be disconnected to test? You can, with one of those capacitor checkers, for example, with the ESR, you can do in-circuit testing. You have to be careful. You have to understand what's going on in the circuitry surrounding the component you're testing. For resistors, you can get a pretty good feeling from just going directly across them without disconnecting them. Transistors and ICs get a little different in that regard. If it's unsoldering a transistor is really not a big deal. It's probably going to need to do that, but it comes with experience. For example, on what you can do in circuit and what you can't do. I would send you to Mr. Carlson's lab on YouTube, who does, that guy's I don't know how to explain it. He's just so good at what he does, and he knows so much, and you can learn a lot from him, especially since he's working with older equipment usually, and he'll go into a circuit, and you can learn from him a lot about what you need to disconnect. I still, David says I still use a Simpson 206. I've got a couple of those, the Simpson, whatever the number is, 260s that are great. Buy the best scope your money can afford by checking the specs. Yeah, the problem, Dennis, is that sometimes folks don't know what to look for in those specs, or they really don't understand what the specifications mean. And to tell you, I'm not an expert at it myself, to tell you the truth. So I rely on the forums and asking questions there, and watching Dave Jones's videos about oscilloscopes when he does teardowns and he does reviews of them. Simpson 260, yep. Good beginning book to learn to use an oscilloscope. The ARRL has one that's pretty good. There's a couple of older ones out there. You're going to need to Google for that, but I'd send you to the ARRL store and just search on the technical tab, and there's a book there. They also have a ebook that's not available in print. It's an ebook on using a digital storage oscilloscope. So there's a couple there you could try there, Sam. And that looks like that's about the last one. Anybody else have any questions? It's been a real treat.
Hey, Dino, I'll just
yeah, go ahead.
I'll throw out a story here that about low dollar multimeters. Work a lot with youth groups, Boy Scouts and the like, and inevitably they will take a multimeter in the ampere setting, hook it to a 9-volt battery, and instantly blow the fuse inside. Well, there are some of these low-cost multimeters that will have a polyfuse inside that will reset, and therefore the instructor doesn't have to go in and manually change the fuse each time. So in order to outfit our little youth group, I wanted to buy a bunch of meters. So I bought samples, about 10 different ones from low-cost overseas suppliers, and tried that silly experiment of hooking them to a 9-volt battery, and found one of them that did not blow a fuse. So I ended up buying 20 of them. And sometime after that, I wanted to figure out exactly what kind of polyfuse was inside. So I took the cover off And lo and behold, it was not a fuse, it was not a polyfuse, it was a 0 ohm resistor that was soldered across the contacts and relying upon the melting of the solder to protect the circuit.
Oh, that's a great story. That's a great story. All right, I don't see any other questions. Just a shameless plug. If you open up this month's QST magazine on page 62, I think you can read an article about our club's coffee and radio net that we've been running for the last year plus, and how we instituted that to try and stay sane during the pandemic. And hopefully the pandemic will be over with next year and we can all be together in person again. Thanks, David, for the opportunity.
Thanks, Dino. Hope to make it out to Williamsburg and see you again soon. All right, everyone. It is that time again. We are going to have drawings for door prizes. And first one that we have from Breadboard Radio, a Woodpecker QRP 60 meter kit, goes to Robert Laramie, VE2 KZW. Also from Breadboard Radio, Clark Turner wins a code practice oscillator that is WA3JPG. Another code practice oscillator from Breadboard Radio goes to Jeff Toye, WG7M. From HF Signals, Asher Farhan's organization, who's generously supported our event today, a new U-Bit X kit goes to Jay Slow, KZ or K4ZLE, and an Antuino kit goes to Gerald LeMay, VA2GJ. From Third Planet Solar, generous donation. We get a lot of crystals from him. A CW Morse PCB key goes to Anthony Vitali, KD8TFR. And another CW Morse PCB key kit goes to Alan Klein, W0NLY. And finally, a CW Morse nano key goes to Farouk Zia, K2FZZ. And those are our door prize drawings for this hour. We're going to take a break for a few minutes, let everybody have an opportunity to go off and do what they need to do. And we'll gather back at the top of the hour and we'll hear from Will Jourdain talking about the new ICOM transceiver. So we will see you then. Welcome back to FDIM 2021. It's been a great day so far. I don't know about you. Out here in Iowa, it's a beautiful day. If I weren't here, I'd be in Xenia, of course, but if I weren't in either place, I'd be outside enjoying the day. But, you know, you only get an FDIM once a year, and this one's been a good one. Next up is Will Jourdain. Afternoon, Will.
Good afternoon, everyone. Thank you for having me today.
I want to thank ICOM so much for their support of FDIM this year. They've been very, very generous in sponsoring and providing door prizes and our grand prize today, an IC 705. And I'd love to hear all about this radio. Are we ready to roll?
Yes, indeed. So everybody, this will be a recorded presentation similar to the previous, but I'll be keeping an eye on the Q&A log here to answer those as they come as I'm able, and then we'll have some time at the end for some further Q&A as well. So without any further ado, I say roll that beautiful bean footage.
Okay, we'll start and see what we can do.
Hello there, everyone. My name is Will Jourdain, AA4WJ. I'm a sales representative for ICOM America, and I am very happy to be here today to talk to you all about the newest member of the ICOM transceiver family. And we seem to have lost audio on the recording there. All band, all mode radio. So HF 6 meters, 2 meters, and 440. And then AM, FM, single sideband of both upper and lower, of course. CW, RIDI, and DV. DV for digital voice. For us today, that will usually mean D-Star. The radio is a QRP rig. And is capable of 5 watts of output power when using the clip-in battery pack and 10 watts of output power when we give it 13.8 volts. Just like what you'd have coming out of your standard power supply that you likely already have in your shack. It is an SDR as well, is the 705, RF direct sampling receiver up to 25 megahertz. And so we like to see that. We like to see the continuation of the ICOM SDR family here in the 705. You can see the size and the weight there on screen as well. It is quite light and quite small as well. Makes it easy to take with you when you go. It does feature a 4.3-inch color touchscreen. And this will be familiar to anyone out there who has used an IC 7300 or an IC 9700. And familiarity was going to be one of our main themes for the presentation today. So you're going to hear me use that word a lot. But it's one of my favorite things about ICOM radios is the continuity that we bring to the table with our user interfaces over multiple radios and even multiple generations of radios sometimes. So keep your ears open for that. But then also we have some nifty new features as well, things like wireless LAN and Bluetooth, and we're going to talk more about those later on, so don't worry. We're going to spend some time digging deeper on those. But before we move on, a few other things to mention. We do have an integrated GPS unit in the 705. It lives just here in the top of the radio above the screen and does some nifty things for us and should be maybe familiar to some of you out there who have used other ICOM rigs from recent memory. And so with that, we will continue on here and take a quick little tour around the outside of the radio so that I can show you what it has to offer. So we'll start with the left side panel here, and we see the antenna connector. This is a BNC or bayonet style, as you may sometimes hear it called. And this is your singular antenna connector. It's where all the RF comes in and goes out. Just below it here, we have the speaker mic connector. This is the same style connector as we have used in our portable radios, at least many of our portable radios. Things like the 51 series and the 31 series handheld. And it is a two-prong style, a 3.5 millimeter and a 2.5 millimeter stereo jack, respectively. And we like this style a whole lot in the 705 because the 705 does have its own front firing speaker. And so what you can do with this two-prong configuration is unplug the speaker jack and either rely on the 705's own front firing speaker, or of course interface your own external speaker should you so choose. A little versatility there for you. We've got a ground lug here, standard chassis ground, nothing too fancy. And then finally here we have the micro SD card slot. Now I will pause here and talk a little bit more about what the SD card is bringing to the table for us, because I always recommend interfacing an SD card with your ICOM radio if it can accept one. You can do many things, the first of which would be you're able to save your settings. So once you get the radio set up and configured how you like it, you can save those settings parameters onto the SD card so that you can load them back into the radio if you ever lose them going forward. And this is important because you also use the SD card to update your firmware. And when you do update your firmware, what will happen is that all of your settings will be put back to factory default. So if you went ahead and saved those settings ahead of time, no worries. You're going to be good to go. You can just load them right back into the radio and pick up right back where you left off. Very powerful. Continuing on to the right-hand side of the radio here, this is where the rest of our I/O lives. So you can see the send and ALC jack here for interfacing a linear, should you so choose. The tuner jack for interfacing an external tuner, should you so choose. And ICOM has recently come out with the companion tuner for the 705, and I will show that to you a little bit later on for those curious to take a look at it. The CW key jack is right here. Worth noting that this is a 3.5 millimeter and not a 1/4 inch, so bear that in mind as you're wiring up your paddles, or that you may need an adapter of some kind. The DC power jack, so of course we mentioned the radio will give us 10 watts of output power when interfaced with 13.8 volt DC, and this is where you would do that, where you would bring that 13.8 volt in. And the 705 does come with a power cable, which terminates in bare ends to make it nice and easy to connect up to your good old power supply, or battery of some kind, should you so choose as well. And then finally here, the micro USB connector lives down here at the bottom. And again, like with the SD card, I will pause and mention a few things about the micro USB connector, because it brings a lot of functionality to the table for us. The first and most obvious is PC connectivity, right? So we can plug the 705 into our PC for things like rig control and programming. But then the radio also has a built-in sound card as well, which is tied to this USB port. So we can leverage that for our HF digital mode enthusiasts out there. We don't need external sound card devices anymore. Rig blasters and signal links, all they are external sound cards. And so now that we have one internal built into the radio, we can get rid of those kinds of devices in our setup and streamline things just a little bit more. We'll continue on here and take a quick look at the back side of the radio. This is where the clip-in battery pack lives. And again, to use this term, I hope it looks familiar to some of you, because this is the same style battery as we have used in some of our handheld radios in the past, things like the 51 series and the 31 series handheld. And indeed, we use this style of battery in some of our commercial radios as well on the other sides of our product lines. So this is where it clips in. The BP272 here is the one that will come with your radio, and it is 1850 milliamps. And there's also a larger size available, a BP307, which weighs in at 3000 milliamps, quite large. Those are the two that we recommend for use with the 705, either the included 272 or the optional 307. There is a smaller size available in this style, style of configuration. We do not recommend that one, though, for the 705, because the 705 was designed around the power characteristics of the larger two. So you're going to get a 272, the middle child with the radio, and then the big boy is available as an option. And down here at the bottom, you can see noted tripod screw hole. And we'll take a quick look at that as we view the final side of the radio, which is bottom. So this is that tripod screw hole, which you'll sometimes hear referred to as a camera mount. Very common connector out there in the world. It's a 1/4-20 threading for those interested in that kind of thing. And because it is so very common, what that means for us is that there are all kinds of accessories out there which will interface with this provision to allow you to mount the 705 in a variety of different locations, places like in the car or in a go box, in the comms van, etc. But if the camera mount does not match your needs, then you do have an alternative in the form of these 4 holes around the perimeter here. This is an industry standard pattern called an AMPS pattern. And because it is an industry standard, similar to the camera mount, that means that there are an absolute wealth of accessories out there that interface perfectly with those 4 holes, again, to give you just that much more variety in your mounting solution, so that you can find the right way to stick the 705 in place where you need it to be. And that concludes the 10-cent tour of the outside of the radio. So let's move on to the fun part. Let's start talking about what the radio can do. And first off, I would like to talk to you a little bit about D-Star. D-Star is, of course, included in the 705 right out of the box. And you can see a pretty good representation of what D-Star operation will look like in the 705 here in the image to the right. So in the top of the image, you see what is called DR mode. DR stands for digital repeater mode, but for our purposes here today, you can think of it as D-Star mode, because what this does is comprise all of the commands that you need for navigating through the D-Star system. It is the most streamlined and easiest way to do so, and we highly recommend that folks that have not tried DR mode in their D-Star radios give it a go. You'll find it in the majority of current generation, current production ICOM radios, and it'll feel familiar to you because it's almost always going to look and operate exactly like you see here. You'll have your to field and your from field, and then again, all of the commands that you need for navigating through D-Star live in one of these 2 fields. Makes it quite easy. You just tap on the field you need, and the kind of settings pop up in a list, and you can change them depending on how you need things set up. So it's very easy and very streamlined. And once you know how to use it in one radio, you're gonna pick it up in no time flat in other radios going forward. The 705 is interesting in that it is now just the 2nd radio in production that is capable of transmitting D-Star on HF. The other one, of course, being the IC7100. And so that's some sort of unique functionality for this radio. It is capable of transmitting the D-Star, a D-Star signal on the HF band. And so that's quite neat. There's a group of guys out there who like toying around with that. You can find them on the air most weekends, just working their way up the bands and trying out D-Star and seeing who they can hear. We also have a pre-programmed repeater list inside of the radio from the factory, and we can utilize the built-in GPS. So you can see here in the top of the image the indicator, which shows us that we have a GPS block. And when we do have a GPS block, the radio is able to pop up a list of nearby repeaters to our location for us to select from. And it does, of course, as I said, work with the pre-programmed list, but it is worth noting that you can associate latitude and longitude coordinates with your analog repeaters as you're programming them in. And in so doing, the radio is then able to pop up those analog machines in the nearby repeater list for you as well. So very nifty, and saves you some time, especially if you travel a lot or if you're taking 705 with you out on the road. It makes it very easy to find the closest machine so that you can get on the air and not waste time trying to figure out where you need to be. So we like that a lot. And then some newer features in the 705, newer and returning features, terminal and access point modes. So these, in essence, are there for folks who are not in range of a D-Star repeater. So what you can do is connect the 705 to your PC with that USB port that we've mentioned already. And then you have access to these two modes. Terminal mode allows you to have the radio connected to your PC and utilize your PC's internet connection to talk to the D-Star network. So you use the microphone just plugged into the radio like it would be ordinarily, and the radio is connected to your PC. And so you key the mic just like you normally would, but instead of going out an antenna, the signal is going to your PC and out over the internet to the D-Star system. And that's terminal mode. Access point mode takes it kind of one step farther back, a little bit more removed. We leave the 705 connected to our PC, but instead of using the attached microphone, we instead talk to the radio with another D-Star radio of some kind, be it a handheld or a mobile, just any other D-Star radio. And then from there, the principle is the same. Instead of going out an antenna, we go to the PC over its internet connection to the world. And there you have it. Then images, and that of course is what you see here in the bottom half of the image on screen. And this again is not brand spanking new, but it is again enhanced with 705. You can see the screen that allows you to send those pictures. But why do I say it's enhanced? Well, previously with this feature, you had to put the image. You have to get the image onto the radio somehow, right? So previously, the way that was accomplished was with the SD card. And you can still do that with the 705, but the 705 has Bluetooth. Don't forget, as we said. So what we can do is we can have some fun with some mobile applications that talk to our 705 via Bluetooth. So I'll go in a bit of a reverse order here, bear with me here, but we already talked about the ability to send photos. So I'd like to start by telling you about the ST4001 that you see here on the right. This is the dedicated picture utility application. And so what it allows us to do is, well, it allows us to do things like edit the image. Now you can always take a picture with your phone and then edit it with, a third-party photo editing application of your choice. And then bring it over to the ST4001. And then from there, you can do some further editing. You can superimpose some text, change the colors and things like this. You can also notably crop the image to maintain the aspect ratio of the radio's own screen. This is why I do recommend going through the ST4001 through this process, because you can scale the image appropriately for the radio screen, which is notable. And then from there, you send the picture to the radio via Bluetooth. Now, it is worth noting that you do still have to have an SD card in the radio for this to work. The radio itself does not have enough memory to store these images unless it has that SD card. Excuse me, so just bear that in mind. You do need the SD card plugged in. But after that, it will work quite easily. And so that's the ST4001 in a nutshell. The RS-MS3 here is pretty simple. It is designed specifically for use with terminal and access point modes that we just talked about. And this guy is designed to provide internet to the 705. So where we talked about having the radio connected to a PC, well, now we can remove that wire and instead feed the 705 an internet signal wirelessly using our phone and the RS-MS3. It's pretty powerful stuff, and we love taking wires out of the equation. We love to do it whenever we can. And then finally here, we've got our jack of all trades app, the RS-MS1. And this guy does, again here, just a little bit of everything. So it is capable of sending images, just like the ST4001 is. However, it does lack the editing capabilities that the ST4001 brings to the table. So I still recommend the ST4001 if picture stuff is what you're most interested in, but the RSMS1 does a lot on top of that. So up here you can see DR mode. Just like I mentioned on the last screen, it looks similar here to how it did in the 705 itself, the to field and the from field, and then again, all of the commands for navigating the D-Star system live within these two fields. So it allows you to control the radio. It allows you to control the radio, of course, in DR mode here, D-Star mode, as we have mentioned, but it also allows you to control the radio in analog mode as well. Things like your power output, your frequencies, your mode, duplex split, things like that, all controllable here with the RSMS1. And then on top of that, other nifty things like the ability to see an actual visual representation of that nearby repeater list that I mentioned earlier. Pictures worth 1,000 words, kind of the theme of this slide here and the previous. So we like to be able to see everything in one glance, and we're allowed to do just exactly that with the RSMS1. So very nifty, very powerful stuff. And finally here, just before we move on, all of these apps are free. These are free downloads from the app stores noted on screen. So I'd encourage you guys to check them out if you haven't already. They're a lot of fun. And of course, all of those apps rely on Bluetooth, the Bluetooth connection that we've talked about a little bit. And so now I'd like to take some more time to talk about that in some more detail. The Bluetooth and wireless LAN built in. We all know Bluetooth at this point. It's fairly ubiquitous in our lives, but I did want to show you what it looks like. So here's the pairing screen. I took this image from my own radio. After I had paired a couple devices. UE Boom is an external Bluetooth speaker. And then Will's AirPods are just a pair of Apple AirPods, which are, of course, just some wireless earbuds. And they both paired up very, very easily. And you can see here that both of these devices have actually been recognized by the 705 as headsets. The UE Boom here, the AirPods kind of speak to themselves, but the UE Boom, my speaker in particular, has a speakerphone functionality. And so the radio was able to recognize that and denotes it as such. It is able to recognize these devices as headsets because we are using very, very standard industry protocols for Bluetooth. There's nothing proprietary in the way that we have implemented Bluetooth in the 705. And so what that means for us is that the vast majority of Bluetooth devices should work and be compatible with this radio. I can't guarantee that every Bluetooth device ever manufactured will be, but my luck has been quite good, and I would wager that yours will be as well. And then to answer the question that I know you're asking, yes, you can use these to transmit. If they have a microphone and the radio recognizes that microphone, you're able to transmit with them. The catch is, of course, that most of these kinds of devices do not usually have a PTT. And so you need to leave the radio in box if that's what you're after, but it can be done, and I have done it. And I've gotten pretty good audio reports too from the old AirPods. So made me pretty happy, pretty jazzed. And so that's Bluetooth. That's, kind of the 10,000 foot overview. Talks to your phone, talks to, headphones and headsets and things like that. But what about wireless LAN? What the heck is that doing in my radio? And the answer is a lot of things. First off, though, this is the connection screen. Nothing too different from what you're used to seeing in just about any other device under the sun. Internet Junior here at the top is my home Wi-Fi network, and you can see other ones that are nearby to me. You just tap on it, tap on the screen, type in your password like you normally would, and bingo bango, you're off to the races connected to the internet. But what do you do? What do you do with it from there? The question remains, and the answer is control. You can control the radio, and more specifically, you can wirelessly control the radio. So this is what you're seeing on screen is the graphic interface for the ICOM RS-BA1 version 2 software. The version 2 is the only version currently available on the market, so that's where we'll focus our attention today. And it is rig control software, and more specifically, it is remote control software. So the sort of general standard setup for RSBA1 would be like this. You would have the radio connected via USB to a PC that's in the shack. And that PC in the shack is running the RSBA1 software and would be what we would refer to in this setup as the server. You would then load the RSBA1 on another computer, ideally a laptop or something portable, and take it with you on vacation or out of town or wherever you're going. From there, you can log back into your home network with the proper network configuration and talk to that server PC that's connected to your radio. And because the two are connected, the PC can then control the radio. So you're remote controlling your radio. You're talking from your laptop to the PC in the shack, which is connected to the radio, and the radio is controlled. That is the sort of general chain of commands for the RSBA1 and how it works. However, the 705 is doing some pretty nifty stuff. It is actually running the server for the RSBA1 on board. It hosts the server inside of itself. So we can completely remove that PC in the shack from the equation. The example remains otherwise exactly the same. So that would be, we have the laptop with us on vacation. We talk back to the 705, which is connected to our Wi-Fi at home. And from there, we can control the radio because it's got the RSBA1 server on board. It's able to understand the commands without having an extra computer attached in the mix. And so there you have it. And it is worth noting that this can all be done locally as well. So the example I gave you was kind of a remote setup, but you can do all of this just in the house as well. No need to be far and wide. The radio can be down in the shack, and you can be up in the easy chair watching TV and have a laptop next to you and listen to and control the radio just like you were sitting directly in front of it. So pretty nifty stuff. And it got even niftier with a recent firmware update. You can see I tease it down there, version 1.20. But I've got a whole slide to that here in a second. So we will get there in just a moment. But first, I would like to talk to you about some digital modes. Digital modes for HF. We've already talked about D-Star, so let's talk about our HF digital modes. So we've already talked about the PC connection and the built-in sound card, but I did want to take a little bit of time just to show you very quickly what it looks like when you operate in these modes. So this is the RTTY decode screen. Should be familiar to those of you who have used 7300. It is all but identical. And then this is your RTTY memory. So this is how you actually send RTTY with the 705. These are customizable, of course, to your taste, and you just tap on it, and it sends it out over the air. And that's great. We like RTTY. RTTY is a lot of fun, but we also like other digital modes as well. You guys may have heard of this little mode called FT8. It seems to be getting some traction here lately, and we have too. We've heard of FT8 as well, and we know that a lot of folks like it. And we also know that a lot of folks sometimes had trouble getting it set up properly. And so with our latest firmware update, version 1.20, we added something very, very nifty. And so let's talk real quick about that firmware update and all of the things that it brought. And before I dive too deep on it here, I want to say that all of my 7300 and 9700 users out there should also take note here, because a lot of these same features that I'm about to talk about were recently brought to those two radios, 7300, 9700 as well. So if you have not updated your firmware since around January, February of this year, 2021, please do so, because this is a big one. This one is worth your time and worth the little bit of effort that it is to go ahead and do it. So here's what the firmware update screen will look like when you do it. I like to show this because I like to note that when you see this screen, you need to press and hold on the button that says yes, just for a second or two, but a quick press won't do it. So Just a note there, when you go to update your firmware, press and hold on that yes button, and then you'll see a little progress bar crawl across. The radio will power cycle itself, and you are all good to go. So version 1.20, the version numbers for the 7300 and the 9700 are different. So just make sure you find the latest one. Go to, just do a Google search, honestly, the easiest way for ICOM firmware update, and it should take you right there. But the version numbers will be different from radio to radio, so just bear that in mind. But some of the new features added are scrolling waterfall, which I'm going to put a hold on and talk to you about in a bit because it's one of my favorites. FT8 settings preset, button customization, and those are the main three that are added to all three of the radios, 705, 7300, 9700. And then unique for the 705 is support for the AH705 auto tuner, which I'll show you here in just a sec, and wireless LAN access point mode. So don't get this confused with terminal and access point modes that we talked about back on the D-Star screen. What wireless LAN access point mode allows us to do is all of those things that we were able to do via Bluetooth, so talking to our applications, sending photos, controlling the radio with the applications, etc. Those things can now be done over wireless LAN as well. So pretty nifty, and means you don't have to be in Bluetooth range. Now you just have to be on the same Wi-Fi network as the radio, and you can do all those things that we mentioned. But the big one. So we'll start at the bottom here, button customization. You can now customize some of the hard buttons on the front of the radio. If you don't need the auto tune button or zero beat or what have you, you can have those buttons turn themselves into something different. There are a lot of options customizable to your taste. So it's worth taking a look and seeing what to see. We're all different. We all use our radios differently. So it's nice to have options. And then probably the biggest one, the one that'll be most exciting to most folks, is the FT8 settings preset. So I went ahead and took a little screenshot, of what that looks like here. And you can see this is a screen that you will not have access to in your radio until you do this firmware update. It has not existed up until this point. It gives us the option to select FT8 as our operating mode. And what this will do is it will flip a bunch of the parameters in the radio, a bunch of settings over to be what is needed for FT8 operation. So it makes it nice and easy, all but a one button setup for FT8. You'll still need to set up the software appropriately, of course, and maybe a few tweaks here and there, but by and large, this is going to get you 99% of the way towards where you need to be to operate FT8, which is fantastic, because it also means that it's going to be very easy for us to go back to normal operating mode. And then, because we love you, we went ahead and added a few blank spaces down here as well, about 4 blank spaces. You can see the 2, and then there are 2 more down below for whatever you like. So if you like to have the radio set up differently when you're doing CW versus when you're doing phone, or when you're contesting versus when you're Sunday morning rag chewing, you can do that now. And you can switch between those settings parameters with a simple push of a button. This used to be something that you could kind of quasi do with the SD card. I mentioned you were able to save your settings. So you could save multiple settings parameters and load those in from the SD card, and it worked. It worked well. But now we've taken some of that out of some of those steps out of the mix. Just added a screen dedicated to exactly doing what we described there. So we love it. I love it, at least. I hope you do too. And it's, again, one of the big reasons why this firmware update is extremely worth your time to do if you have not already. And then finally here, the scrolling waterfall I mentioned. It is one of my most favorite additions. This, candidly here, folks, is how I've wanted the waterfall to work since day one. The waterfall has had 2 modes previously, centered and fixed mode, which were selectable via this button down here. You press and hold on it, or rather you just quick tap on it and it would switch between the 2. But now, if you press and hold on this button after doing the firmware update, you get what is called scroll mode. You can see that here in orange at the top of our scope. And what that does is it allows us to operate on band edges. So you can see here, we're on 14.200 is our center frequency. And I've got the radio configured for plus and minus 10 on our center frequency. So 14.19 up to 14.21. And traditionally, if we had been in fixed mode, we'd have these same band edges. And when I scrolled, once I got to 14.211, my cursor would disappear off the screen. I wouldn't be able to see it until I scrolled back into, within the span here noted. And that was not ideal for a lot of folks. And so what we've done is we've added scroll mode. So we continue to operate in band edges, but now when you scroll past one of your edges, the edges change. So the emphasis here, the highlight is mine. This will not be on your radio screen, don't worry. But you can see here in the second image, I scrolled up to 14.211. The frequency readouts momentarily get a little bit bigger, or the band edge readouts rather get a little bit bigger to show you that they've changed. And so here you can see we're still on plus and minus 10. So we've got 14.21, which used to be our right-hand boundary, is now our left-hand boundary. And our new right-hand boundary is still 10 up from our center at 14.23. So your span stays the same, but it follows you along as you scroll. So instead of losing sight of your cursor and having to wonder where it is or wonder what the spectrum around it looks like, because that's what the waterfall is for, of course, you now can always see it, and it's fantastic. And it's the mode that my waterfall personally will stay in from now until the end of time. And I highly encourage you all to check it out and give it a try as well, because it's really, really a great addition to what was already a fantastic feature in the waterfall band adapter. And finally here, we're coming towards the end of the presentation, so thank you for bearing with me. But as promised, I wanted to show you one of our newest products, and that is the AH705. This is the companion antenna tuner for the 705. So you can see here, nothing too fancy, nothing too complicated. You've got singular BNC as the RF input to match the BNC on the 705 itself. So it makes interfacing very easy with just the BNC to BNC pigtail. Control for connecting to the radio to that tuner jack that we saw way back when we looked around the outside of the rig. And then DC input for giving it some power. And then, of course, your antenna output is standard SO239. Since most of the types of antennas we're going to need a tuner for, are going to terminate in the PL259. And then, of course, ground is a wing nut to make it nice and easy to ground this bad boy, should you so desire. It's a little bit hard to gauge the size of the thing, I know, from the images here on your screen, but it is roughly the same footprint size as 705, maybe a little bit bigger, and about half the height as the radio sits on the table with the screen up. So there you go, the AH705 available now from your favorite amateur radio retailer of choice. Give them a call and see what they've got in stock. And then finally, we've reached the penultimate slide here. And I wanted to talk to you guys. I would be remiss, in fact, if I did not talk to you guys about the battery life. It was probably the biggest question that we got about the 705 before it was released on the market. And so I like to talk about it here in this presentation. The 705 is doing a lot of work behind the scenes to help make sure that you get the most talk time out of your battery. So all kinds of features available to you to help save the battery life. First of all, probably my favorite is just the quick screen off feature. So you can quick press on the power button. A long press will turn the radio on or off respectively, but the quick press will just turn the screen off. So the indicator light here goes amber, but you can see the TXRX light over here is still green. So the radio is still receiving, and indeed the radio will still transmit. And further, the radio is actually still active. It can be tuned. If you bump the VFO knob, you'll move yourself off frequency. So I'd recommend putting, locking the screen, locking the VFO knob before you put it in this mode. But this will save you a lot of battery, turning the screen off. And then other features as well that you can turn off through internal settings if you do not need them are the GPS, the wireless LAN, and the Bluetooth. All of these are primary suspects for current consumption. And so if you do not need them, I recommend turning them off. if you find yourself in a situation where you do need your GPS coordinates and you're not going to be moving, you can actually have the radio import your current GPS latitude, longitude as a manual location, so that you can turn the GPS off but still have that lat longe info in the radio and accessible to you. Again, if it's needed. If you do need the GPS active while you're moving, then you need to leave it turned on, of course. But you do have options to save that battery. And then finally here, just a shout out to the boys over at Amateur Logic TV, the venerable George and Tommy. Shot a video with Ray Novak of ICOM, showing a lot of this in action. In fact, where I got this screen capture from that video, and they do exactly what it looks like they did. They hooked the 705 up to the good old fluke here, and then they go down this list, start turning stuff off, turning it back on, and letting you see in real time what it does to the current consumption of the battery. So highly recommend checking out Amateur Logic TV just in general, and then also specifically this video, the IC705 minimum current tweaks, if you're interested in that kind of thing. And then if you are interested in that kind of thing, I will say, get out there and don't stop at just Amateur Logic. Get out there and see what else is going on the web. Things are starting to get back to normal here a little bit more in our lives, which is absolutely fantastic. But as we moved our way through this past year, amateur radio really, really shined, and the amateur radio community online really shined and came up into its own. There are all kinds of great YouTube channels out there. I've listed some here. By no means is this all of them. I could not have begun to fit all of them in a single slide. So I highly recommend getting out there and getting engaged with the community online. Of course, get back engaged with the community in person just as soon as you can, as soon as it's safe. But also, there's a great wealth of resources for us out there on the web. Places like YouTube, they're making such fantastic content, hours upon countless hours of marvelous amateur radio content for us to watch and enjoy and learn from. And then places like Facebook and other user groups allow us to share our knowledge and leech upon the knowledge of others to enhance our enjoyment of our hobby and spread the love of amateur radio. And then blogs and things like this. There are plenty of places out there where folks are talking about what they're doing in the hobby and what they're enjoying, and some of the things that they've learned through their journey in amateur radio. So as LeVar Burton said in Reading Rainbow back in the day, don't just take my word for it. Get out there and see what your fellow hams are saying about the 705, about ICOM in general, about amateur radio in general. And I bet that you will find a lot of stuff to love out there. And so with that concludes my presentation here, my slide deck. And so I will throw it back to everyone in the audience for some questions. So thank you for your time, everyone.
Thank you very much, Will. Looks like we do have some questions. I'll let you just read them.
Right, so I believe I got to a few there as the show was rolling, so to speak, but a few that I see that I have not yet gotten to. AB7 Whiskey Tango asks, do we sell a matching amp if you want to go QRO? No, ICOM does not sell a matching amplifier for the 705. I do know that there are some options out there for people that are looking for a QRP amplifier from various other manufacturers. In that regard, I would say reach out to your favorite retailer of choice and find out what they recommend from their own product lines. They carry a lot of stuff, and they have got a lot of experience collectively amongst their sales teams, and they'll be able to point you towards what's going to work well for the 705. Let's see here. Delta Bravo Juliet Mike Whiskey is the name that I see here. Asks, he likes the scroll feature, but any consideration to a half screen scroll rather than a full screen scroll? It's always possible. Our engineers always like to iterate and improve and add features that folks are asking for. So I would say that while I do not know of any such plans for the foreseeable future, it's not impossible. So always keep your eyes on the various firmware. Well, first of all, keep your eyes on the various ICOM social media outlets out there for announcements that we make in regards to feature additions and firmware updates and things like that. And then also just keep your eye on the firmware update page itself. Very often it'll be that it gets released late night in Japan, and so there's a little bit of time before we at ICOM America are able to wake up and get the news out to you that it's sitting there waiting for you. So keep your eyes on all those places, and we very much like to keep our radios up to speed and updated to the best of our ability with the features that folks are looking for. Let me see. Any chance of adding a CWD code? Asks anonymous attendee. Not at this time, at least not that I'm aware of. One of the issues that ends up getting run into with integrated CWD coders is that they're historically not super reliable. CW is a human generated signal. And so it can be difficult for a computer to parse that because everybody sends CW differently, different speeds, different, different rise times, stuff like that. So they're not historically super accurate, and adding anything like that into the radio, anything that we add physically, hardware wise into the radio increases the price as well. So that's always a consideration that we like to take into account also. Unlikely that we will see CWD code added to the 705. David Martin asks, are the amps holes threaded? And yes, absolutely, they certainly are. They need to be in order to accept the accessories, the mounting accessories, so that the thing doesn't slip and slide around while it's mounted. So yes, absolutely, amps holes are threaded. Let me see anything else that I've missed. Oh, I'm still scrolling. Someone has a question. Shirley Dulce asks a question about CW. What is the receiver latency? How fast is TR switching? Is the switching electronic or relay? It is a relay. And as far as the latency is concerned, I don't know the exact specification. However, I will say that there are a lot of folks out there who are using the 705 for CW. I kind of mentioned the YouTube sphere at the end of my presentation there. There's one gentleman in particular named OH, his call sign is OH8STN. He's an American expat living over in Finland, I believe it is. And he is doing a lot of stuff with the 705, including digital modes and stuff like that. So he would be another great resource that I would recommend to check out for things like that. Let me see here. When considering, Paul, Whiskey 6, Papa November Golf asks, when considering field use, what are the weatherproofing specs? The 705 does not have any weatherproofing specs. So some of our handheld radios, for instance, will carry what's called an IP rating or an ingress protection rating. But the 705 is not IP rated. I would say it's probably splash resistant, but it's certainly not rated for submersion, and I would bring it in from the rain if you find yourself caught out in it. So no WX rating for the 705. OH8STN does not do CW. That is correct. He is more of an HF digital mode kind of guy. That is fair. Let's see, anything else? I don't see any other questions in the log, or have any of the moderators spotted one that I may have missed along the way, or are there any more that anybody else has got burning in their minds there?
There's one in chat. Buddy Brannon asks, what about voice readout? Does this rig have it?
It does. Yes, indeed, it does. You can do it with a quick press of a button on the front of the radio. If you look at my little background here, you can actually see the button just down here. So it doubles as the lock button. It's the button just here to the left of the bottom half of the VFO knob. So you press and hold it and it'll lock the VFO knob, but a quick press on that button is for speech, and it'll read out your frequency, your mode, and a few other various general operating points of interest.
Well, I've got a question, just out of curiosity. I don't believe the 705 does full duplex for satellite operation. Is that correct?
That is correct. Single receiver inside the 705, so not the ideal candidate for sat work.
Thanks.
Now let me switch over to the chat here. I see some popping up over there. Our received signal architecture for greater than 25 megahertz. Sure, it's a single down conversion. Yeah, it's an SDR up to 25, and then from 25 on, standard mechanical superhet.
I'll throw out one here. What's the receiver chip used? A to D or otherwise transceiver chip?
That is a good question, and unfortunately, I do not have that information available to me. The OEM specifications of internal components is not something that is generally shared outside of our engineering department.
Okay, fair enough.
There's another one that says, does it connect to the AH4 tuner?
It can connect to the AH4, yes. However, the AH705, well, I mean, yes, absolutely you can. And the 705 is using the same protocols. The issue is the actual interfacing itself. The AH705 has got just a 3.5 millimeter stereo that plugs into the tuner jack of the 705, whereas most things for the AH704 are using that 4-pin inline Molex connector. So the 705 does not have an easy kind of turnkey plug and play interface with the 705. So there would be some hoops to jump through there, which is why we like the AH705 because it is plug and play, nice and easy. Let's see. GPS over Wi-Fi AP to set laptop clock? I do not believe so. That is not something that I believe that we have the capability of. Let's see. Someone mentions the form factor, which makes it difficult to angle it on the table. In fact, I can see what you're saying, and of course, as you see it here in the image, it's sitting flat. There actually is a little bit of a chamfer, though, on the back of the radio that allows you to kind of take it and knock it back one. It doesn't sit in that orientation by itself super easily, but you're usually going to have at least one hand on the radio to begin with. Plus, we have those provisions on the bottom for various mounting solutions, and the world of 3D printing enthusiasts out there are coming up with all kinds of cool designs that they've made available to our fellow hams on the web. And then there are also some other commercial outfits out there that are manufacturing and selling through various retailers, brackets and adapters and things like this that allow you to situate the 705 as you see fit. It's one of the cool things about amateur radio. We're good at making things, we're good at designing things, and some of the more generous members of our community do that legwork for us. So all kinds of cool stuff out there, various other like handles and things that you can get. A lot of them are using these connecting provisions on the bottom that I mentioned. So again, another great thing to talk to your favorite retailer about what they have available, or those forums and things like that, Facebook groups. I see a lot of these things, the 3D printing designs and what have you, in Facebook groups and the groups.io forums. Folks are always eager to share what they've been working on. Let's see. I think we may have tapped out. Are there any more questions over phone here, or any that I may have missed in the chat log? Nothing heard, nothing heard. You guys are making it too easy. Well, okay. If there are no more questions and nothing else that I see pop up in the chat here, that will conclude my time here, and we've run pretty close to the end. So I will kick it back to To the host here, to David, I say take it back over. And just for me, again, thank you for hosting this today. Thank you for letting me be here to talk about our newest radio. And good luck to everybody here. I hope you have better luck than I do when it comes to the grand prize drawing, because the 705 is a really fun one to have.
Well, thanks so much, Will. Really appreciate your time and being here today. Was a fun presentation. I think everybody is highly motivated now to check this out. Okay, we'll do our business now with our door prize drawings. So let's see what we've got next on our list. And we have donations also from Third Planet Solar, another bunch of great prizes. We have a Kanga M0XPD Arduino DDS board, and this goes to Alan Wolfrey, VA3IAW. A Kanga Sudden-2 SMD 40-meter receiver. This goes to Richard Black, K4RAB. We have a Pixie Switch 2 with a 40-meter crystal band pack, which goes to Richard Haynes, K5ANR. A SKCC QRP crystal pack, which goes to Stephen Roberts, M70YR. A HC49 crystal sampler pack to Keith Chambers, G0HKC. A H49C crystal sampler pack to John Putnam, AC9UV. And an HW8 upgrade pack, which goes to David Brown, KC or K3CTN. From Jack Purdom, one of our speakers earlier today, a pair of his books. Beginning C for Microcontrollers goes to Tom Englund, N38Z. And Microcontroller Projects for Amateur Radio goes to Roman Downer, N4SC. All of these will be shipped to you. You do not need to be present to win. So give us a week or so to get things wrapped up and in the mail. And definitely thank our generous donors who've made these door prizes possible. Okay, we now come to our next speaker, Hans Summers. Barely needs an introduction here. He's been a frequent speaker and has been very well received. Always has really good material to share with us. We're going to give you a couple of minutes to stand up and stretch, and we'll start his presentation at the beginning of the hour.
This is Hans Golf 0 Uniform Papa Lima.
How are you today, Hans?
Hi, Dave. Everything good here? It's about 9 p.m. here, so quite a lot later than most of you.
I'm glad I'm not keeping you up that much later.
We'll be later tonight in the evening session. It'll be 3 a.m. here.
Oh, goodness, yeah. Well, want to give a brief introduction to your video?
So I'm going to talk about the high altitude ballooning projects that I've been working on with Dave, the E3 KCL, for the last 6 years or so, and trying to develop this into a product, into a tracker for high altitude ballooning. So we're going to talk about some of the challenges and solutions and how much fun you can have with this kind of really interesting niche of the hobby, really.
Outstanding. Well, Bill, let's start our video here and get started.
Okay, let's see if I can get it up.
Hello, this is Hans Golf 0 Uniform Papa Lima. Today I'm going to talk about
See and
using
hear that all
QRP
right?
transmitters to track high altitude.
It's good.
balloons.
Okay.
The first question is, why do we use QRP? And the answers for this are pretty much that you're putting a radio on a balloon, and the balloon can only carry a very limited payload. So you couldn't attach any basically any boat anchors or a kilowatt linear. You couldn't attach a car battery to power the whole thing. And so you really are limited to low power. So it's a perfect application for QRP. There are two types of high altitude balloons, and the first is weather balloons. They're made of a latex rubbery type of material, typically 2 to 5 meters in diameter. They can carry quite a large payload, perhaps even a kilogram or two, and they basically fly up and up and up, and as they go up and the air pressure decreases, the latex continues to stretch without limit until eventually the balloon bursts and down it comes. Typically people put a parachute on these, and the chase teams try and recover the balloon, and they fit cameras on board and take photographs and videos. So you can take very nice pictures that show the curvature of the earth and the sky is black. And tracking typically uses very short range VHF, UHF radios such as APRS and data transceivers that only need to cover a few hundred kilometers at most. These projects are quite large, big projects, and often undertaken by university teams. You can see here a picture I found showing an example payload for one of these high altitude balloons using the latex type. And it contains a camera there for taking photographs and videos. There's a 900 megahertz radio modem with 64 kilometers range. There's a cellular modem with a cellular antenna and a GPS antenna, a temperature sensor, power supplies. Now with one of these flights, you clearly don't have to worry too much about the weight that it can carry, and the power source can be a battery that will last for a few hours because the flight will all be over in a few hours. Second type of balloon is what we're going to concentrate on today and is known as a floater balloon. It's also known as super pressure balloon or a Pico balloon. And these are very small balloons, typically only a meter in diameter and a sort of pillow shape often. And they're a typical type of mylar film balloon that you can find in party shops all over the world. So there's nothing unusual about these balloons. Now, the important thing is that they're inelastic. As they float upwards in the atmosphere, they reach an altitude where the gas inside fully inflates the balloon. So you typically launch them very underinflated, and they reach an equilibrium with the external pressure where they can't expand anymore. And at that point, they reach this equilibrium altitude where they don't burst and they just float along in the wind. And they can go for a very, very long distance. They can fly around the world. We've had one that's flown around the world 12 times, lasting several months in duration. The downside is they have a very low payload capability, and that gives quite considerable communications challenges. We need a transmitter that has very low weight and is very small. It also needs a GPS on board and a power source and of course an antenna for both the radio and the GPS. At the same time, the communications have got to cover thousands of miles of ocean, because this transmitter is not just going straight up and straight down like on a latex balloon. This transmitter is going to reach an equilibrium altitude at which it's going to float around the world potentially. So clearly the VHF, the short range of VHF is no good for this, and we typically tend to use HF communications with a good propagation during the daytime, such as 20 meters or 30 meters, and really, really very low power, 10 or 20 milliwatts is quite typical. And this is why the talk is titled Extreme QRP, because we have to be tiny, with tiny power, tiny transmitters, very, very lightweight, typically no more than 10 grams, which is less than 1/3 of an ounce. So weak signal techniques, as you'll come to see, including whisper, are the very important savior to the day here. Well, we all stand on the shoulders of giants, and in this case, I had been following the flights of Leo M0XER, who flew 64 billion flights up until July 2014, and typically was using UHF transmitters with a weight of about 10 to 15 grams, and a couple of those are pictured here. He used sometimes solar panels and in some cases a battery, a fixed battery, typically only about 10 milliwatts transmitter. In the end, he had 3 flights which circumnavigated the world, and one of those went round 6 times. The other giant that I had been following was VK3YT, Andy, and he has quite a few flights, and he's still flying balloons today. He flew various experiments with VHF, UHF, and HF transmitters. The ones that were most interesting to me, because of the continuity of transmissions even across oceans, were the HF transmitters. And he again was using 20 meters, 30 meters whisper and JT9, which is another weak signal mode, and using standard type of party balloons. There's a photograph here that shows one of his trackers, and the weight of the board there is 2.34 grams. And you can see on this tracker, there's a microcontroller, there's a GPS on the left-hand side there, and there's a ceramic chip antenna, which is the GPS antenna. In early 2014, I had an email from Dave, VE3KCL, and Dave was interested in putting an Ultimate 3S kit on a balloon. The Ultimate 3S is one of the kits which I designed for QRP Labs, and which was the main kit, main product back in 2014. It can transmit a variety of weak signal modes, including whisper and including JT9 and various other weak signal modes, narrowband modes, which are ideal for this long distance communication because of the very high signal to noise ratio. So of course, there was no way that Dave was going to fly that black box that you see there in the photograph on the top right on the balloon, which was much too heavy. And so he developed a system using a series of off-the-shelf modules that weighed around 30 to 35 grams and included an Arduino Nano, which includes the Atmega 328 processor, the same processor as used in the Ultimate 3S, and the QRP Labs SI53518 synthesizer, which you can see there on the bottom left in the bottom photograph, a GPS module that you see there on the bottom right, battery and boost regulator, which are on the top and top center. Of course, he also has to attach antennas for the HF radio and for the GPS. So this email from Dave really initiated a long series of developments and friendship which has spanned the intervening years and continues to this day. This is a block diagram of the VE3KCL payload back in the beginning there in 2014. And you can see the various modules which I have spoken about and how they connected together. It's important to realize the Arduino Nano was actually not acting as an Arduino Nano at all. It was programmed with a special version of the QRP Labs Ultimate 3S firmware. And it was only used really on the flight because it was a much smaller board than the QRP Labs board, which had never been designed with ballooning in mind. Here is an example of one of the solar panel arrangements that Dave for E3KCL used on his flight. In this case, a series of 8 solar panels. These solar panels are incredibly fragile, very, very thin glass and quite difficult to solder together. Dave mounts those on this pink polystyrene insulation material. The antennas that we use are typically dipole antennas for the HF side of things. The easiest way to do this is to have the transmitter at the middle of the dipole directly feeding the dipole legs, and one end of the dipole tied to the balloon with the other end of the dipole hanging down freely. Dave has also experimented with double band antennas using 3 legs, 2 legs hanging down, separated somewhat. This is always involving compromises, like any multi-band antenna, and in the more recent flights we've concentrated on 20 meters. The GPS antenna is interesting, and a lot of people use this small chip antenna shown in the bottom left here. These are not particularly sensitive. They're very good in a cell phone where there's very limited space, but they're not particularly sensitive. A much more sensitive antenna is the patch antenna shown there in the photograph on the left, but there's quite a significant weight penalty to that, which makes it unsuitable for use on the balloons. The antenna we've found most effective is a simple dipole antenna. At 1575 megahertz, the quarter wave length is something like 45 millimeters, and so we make a dipole antenna as shown there on one of the early prototypes of the tracker, and 45 millimeters on each leg, and then a twisted wire feed line which provides a very good 50 ohm match to the receiver. Now on to communications modes. As I've mentioned, VHF and UHF APRS and other data transceivers in the UHF range are fine for short range, but no good for the global floater balloons that we're talking about here. Andy VK3YT developed a special telemetry on JT9. JT9 carries 13 characters, and he purposed those to carry his balloon telemetry. And he required special software that had to be installed and run by volunteer receiver stations. So the disadvantage there is a limited number of stations to monitor for the signals around the world. Whisper is ideal insofar as having a global network of receiving stations, but the disadvantage there is a very limited information content consisting of just the 4-character grid square. The 4-character grid square has a typical size of around 100 miles on each side, depending on what latitude you're at. So it doesn't give a very precise location information. And of course, it doesn't give you any information about altitude. So some more information about the weak signal propagation reporter mode created by Joe K1JT. It's a very popular mode worldwide and used mainly as a propagation tool. It's got very powerful narrow bandwidth forward error correction, which gives it a very high signal to noise ratio, and it can be copied even below the noise. So it encodes 50 bits of information that include the call sign, which is 4 to 6 characters of call sign without a prefix or a suffix, and a grid square, 4-character grid square, as I mentioned, which only has a resolution of about 100 miles, and a transmission power, which is in dBm. So the transmission is made up of 162 symbols, each one of which is one of 4 tones, which are spaced by only 1.46 hertz. So it gives the message a 6 hertz bandwidth, and the message transmission takes almost 2 minutes, 1 minute 52 seconds, in fact. And shown here on the picture on the bottom is a series of 3 whisper transmissions, so you can see what they would look like on a waterfall. The receiving stations decode and log the whisper reports that they receive to an internet database, so that the then transmitter station, or indeed the receiving stations or anybody else, can go onto this WhisperNet website and look at the database showing who has been receiving your signal or whose signal you are receiving. And there's a map which you can use which shows who has been receiving your signal. So this example, the map here shows some transmissions that I made on 20 meters and the stations that were receiving me. So as I mentioned, Dave VE3KCL and I started a long collaboration which has gone on now for the last 6 or 7 years, and we bounce ideas back and forth between each other, and the roles that we play in the project are that I am developing the software and the electronics and the PCB layouts. Dave is doing what I call the hard work, all the actual launches and the construction of the boards and filling the balloons with gas and all of the early morning excursions to the beach to launch the balloons. So all the hard work there, as I call it. He's also doing a lot of experiments on the electronic side as well, particularly with the power supplies. So very early on, after the first few flights that Dave made with the Spatial Ultimate 3S firmware version, I developed this balloon telemetry protocol, which actually sits on top of WSPR. And it transmits one normal WSPR message, which sends the Maidenhead grid square, for example, here shown IO90. And then a second message, which has the same format, but encodes all of the X's that you see there. So four of the 6 characters of the call sign, as well as the locator characters and the power characters. And it identifies in the WSPRnet database these telemetry transmissions by using a call sign that starts with 0, 1, or Q. These call signs have never been used by the ITU. They're not issued by the ITU. And so we're able to use them to create 30 unique channels for telemetry, which cover 0, 1, and Q first characters with a third character of 0 to 9. The beauty of this system is that the WSPR reporting network globally automatically receives all the balloon data transmissions without any special software, without any of the WSPR monitoring stations needing to do anything. And so all of these reports are logged into the internet database where they can be extracted and used to retrieve the telemetry and the position information. So in our case, we are encoding the X characters in the WSPR message to contain the telemetry containing the 5th and 6th Maidenhead subsquare characters, so we get a much higher position accuracy of just a few miles, the Maidenhead grid subsquare. We get the altitude information to a resolution of 20 meters, temperature, battery voltage, ground speed, and GPS status, which is basically whether or not the GPS has got a valid fix and how many satellites are being received. Here I show an example decoding. You can see at the top there 2 transmissions on WSPR, which are 2 minutes apart, as all WSPR transmissions are. The first one is a standard WSPR transmission, and the second one is a telemetry transmission, where the first character in this case is 0, and the third character is 0 also. All the other characters in that transmission are carrying the telemetry, which I mentioned on the previous slide. So in this case, it's VE3KCL call sign, and it shows the full 6 characters of his locator, an altitude of 80 meters, temperature of 36 centigrade, 3.8 volts battery, and a ground speed of 0. He was actually testing this on the ground. I developed a spreadsheet which extracts all of the telemetry reports from the WSPRnet database once every couple of minutes. And when it finds a report for the balloon, which are transmitted during daytime once every 10 minutes, it updates this Google map. So shown here is one of our balloons, which was quite a successful balloon flight, and it's on its 7th lap around the world. We started using color coding of each lap corresponding to the resistor color codes. So you can see there the end of this flight currently, or the current position, is over Europe and is a purple color, which means it's on its 7th lap. We also get back all of this information on the altitude and the ground speed, temperature and battery voltage, and these are all plotted onto graphs. Now to the actual balloon hardware. There have been 3 versions of hardware, 3 main versions, and firstly, the off-the-shelf version of the Ultimate 3S, which I showed before, and I think they've actually designed some PCBs for this in the end. These were running special versions of the Ultimate 3S firmware, and there were 26 flights in total. It was basically the Ultimate 3S, but without the LCD and the buttons and the large circuit board, and running a special firmware that did the balloon telemetry, the WSPR telemetry. That then evolved into a product development for QRP Labs, which was called the Ultimate 3B, or U3B for short, a really tiny board, which was also using the Atmega 328 processor and running a basic interpreter for the flight configuration. 28 flights were run with that, including many circumnavigating flights, and the hardware has always performed very well, very successfully. 2 years ago, that changed into the Ultimate 4B product development, which uses the STM32 processor and a much more advanced operating system. There have been 19 flights of that to date. Here are some pictures of the Ultimate 3B, a really tiny circuit board, just 1.5 times 0.5 inches and weighing only 1.5 grams, which is 0.05 ounces. SMD components on both sides of the board, and you can see a line of GPIO along the board there, which is all accessible by the basic interpreter, and so you can make your own enhancements to the system if you wish. Here are some more pictures of the U3B prototype with my hand for reference, so you can see the tiny scale of the thing. We did later develop a larger PCB for it, about twice the size, which was just easier to work with and not very much heavier. So the U3B was using the same processor as the Ultimate 3S, the Atmega 328, but a very different firmware. The U3B runs a virtual machine, which I developed, and a basic interpreter, which controls all aspects of the transmitter, the GPS, and the GPIO pins, sensors if you want to read them, and so on. So you basically configure over the serial port a basic program which configures exactly how you want the flight computer to operate. It provides a lot of flexibility and at the same time a simple way of setting up a flight. Well, Dave and I were at the FDIM 2019, 2 years ago now, at the Holiday Inn Fairborn in Dayton, and we were discussing one evening the tracker, and as a result of that, the U3B tracker product development evolved into the U4B tracker, and that became the new product development. This uses the STM32F103 processor, a much more powerful 32-bit ARM processor with a USB peripheral that lets me have an onboard USB interface for configuration of the tracker. The board size is the same and the weight approximately the same, also 1.5 grams, and slightly smaller board size, in fact. The same SI53518 synthesizer as the transmitter and an LM75 temperature sensor, and it now has a TCXO reference for very, very stable frequency output. The firmware is now completely new, called QDOS, QRP Labs Disk Operating System. The pun was not entirely unintentional. Here's a photograph of one side of the Ultimate 4B tracker, and you can see here at the top this section of board, which in the final production version will hold a USB mini connector. And this section of board is designed to be snapped off along this row of holes here. So once you've configured it as you want it and finished testing, you'll snap off this section for weight reduction. After that, the board weighs about 1.5 grams. And you can see here the STM32F103 processor. On the left side, here is the SI53518 synthesizer, which is used as a transmitter and a TCXO reference for it. And on the right side here, this is the LM75 temperature sensor. On the next page here, we see a photograph of the other side of the board. So again, this board has got components on both sides. And on this one, we have the SIM28M GPS module. And here is an EEPROM, which is used for storing the program. We also see again this row of GPIO pads along the bottom here. So you can connect to this any I2C sensors, any serial connection that you wanted, or any single analog to digital conversion inputs here. You can use these inputs for those purposes, all under control of the basic program. Now I'll give a demonstration of how the QDOS system works. And I'm using here a terminal emulator called PuTTY on Linux, but in principle, any terminal emulator could be used. And all you have to do is connect that to the USB device, which is the U4B. And so you come in and you've got a menu here, which you can scroll up and down. And the idea is that there's a very, very basic flight configuration page here where you'd input your call sign and the transmission frequency and some basic parameters. And that would allow you to run a simple tracking flight without getting any further involved into anything. Just simply configure your call sign and the operating frequency, and away you go. However, if you do want to get into further details, the functionality is extremely rich. And so there's a file manager here, which you can create new directories. You can open files from here. So this is a directory called hands, and it contains a directory called test. You can come back up the file manager directory tree, and the initial program which is run is this one called main, but you can have as many other programs here as you want, and the program can call out to another program as well, so you can have sub programs. I can then edit any file I want to, and there's a full screen text editor built in, so that you don't need to do any development whatsoever on the host PC. You just literally run a command window or a terminal window onto the U4B and do all your work on here. In the file manager, there's also a disk manager here, which shows the status of the disk and how much free space there is. The disk is actually written on the EEPROM. There's 128K EEPROM. As you see here at the bottom, 98% free in this example. And this will show you the structure of the disk and how fragmented it is, and allow you to defragment it if you need to. There's also a command line where you can do pretty much everything that you can do from within the file manager. For example, you can also look at the contents of programs. So let me just type the test program, and you see that it just has a loop in it. I can also run that from the command line here. And I'm also able to execute any basic statements directly from the command line, which is very useful for testing sensors and all kind of testing parts of the program. There's a hardware test feature here that allows me to test all aspects of the hardware and see any failures. In this case, the failures are highlighted in red. There's a factory reset option, which gets me straight back to the factory configuration with a default set of programs on it. And finally here, there's a firmware update option. The firmware update is extremely easy. The device appears as a USB flash drive, and you simply copy in the new firmware file. You can run the program here and for test purposes. And in the editor, I can open a file from the operating system, such as this one, and I can compile the file. I can also debug the file, and what I have here is an integrated debugger in the device itself, where I can step through line by line here, or I can just run the program here back in the editor. And now back to the front page. So you can see it's a complete operating system with a text editor, a way to edit programs, a way to debug programs step by step, to run the entire program. There's a file manager for setting up sub-programs and editing them, and a command line with various functionality to test the hardware, edit files, create directories, create files, everything like that. So a really nice complete system on a very tiny board with very flexible interfaces. It has the input-output pins. It has access to any sensors on the I2C bus, and it can transmit any of the modes which can be transmitted by the Ultimate 3S, including Whisper, JT9, JT65, QRSS modes, plain CW, and all the modes which the Ultimate 3S supports. In summary, Kudos has a 128K disk implemented on EEPROM chip. It has a simple flight configuration tool which allows you to get started quickly without needing to get into any further details. It has a suite of applications, including a text editor for its basic programming language, a debugger, file manager, and command line. There are 8 pads along the edge of the board which can be configured as analog inputs, digital input-output pins, or the I2C bus is exposed for connecting further sensors or serial data sensors. So there's a lot of expansion capabilities possible, and you can log data to files on the disk. So there's a lot of functionality there that probably actually open up the small board to further applications as well as ballooning. Well, ballooning isn't easy. Be prepared for failures, perhaps multiple failures, and to learn as you go and to get better at it. Dave's first flight, the S1 flight, lasted only 2.5 hours, and he's gone from that point to being able to reliably launch balloons that work almost every time and circumnavigate the globe reliably, often multiple times. We have a flight that's running at the moment that is now on its 12th lap as I make this. One of the main enemies is weather, and you need to get high enough to be above the weather. 11,000 meters is a good height to aim for, and once you're above that, then you pretty much have avoided nearly all of the bad weather. If you encounter clouds, that will ice up the balloon surface and increase the weight, which will cause you to come down. So you need to launch on a day which doesn't have clouds, which doesn't have wind, which could cause the balloon to be driven into the ground or into nearby obstacles. You can have balloon failures due to overfilling it, miscalculating the amount of gas you need at the launch. You can have electronics failures with launch dramas. All kinds of launch dramas can happen. The antenna can get tangled up. The tracker can be dragged along the ground in a sudden downdraft. All sorts of things can go wrong. And so overall, the whole topic really does require persistence. So we'll talk about some of the other things you'll need to know if you're crazy enough to attempt balloon flights, one of which is regulations. So regulations vary by country, and do check the regulations in your particular country. For example, the UK does not allow aeronautical transmissions in its amateur radio license at all. However, regulations anyway are often a grey area. What is allowed for an unattended beacon operation, which is arguably what a balloon transmission is, and SEPT licensing is another question. As your license transits into another country, as it flies over another country, what does that allow and what does it not allow? It doesn't actually allow unattended beacon operation. So, and then again, you could fly over all kinds of countries. You could fly over North Korea, for example, and perhaps they wouldn't allow your license to operate over their airspace. And so it's a somewhat grey area, how far you worry about such a thing. But at the end of the day, you're talking about a very small, very light transmitter flying at a very high altitude. It's not really likely to be noticed, and it's not likely that your 20 milliwatts is going to disturb anybody. So you have to interpret it how you see fit. Safety is another important issue. It goes without saying you should avoid power lines anywhere near your launch site, which could get tangled up in your antenna. You should launch in a large open area without people or traffic that you can trip over as you run around trying to get your precious tracker off the ground safely without smashing the solar panels. Then consider the gas you're going to use. Helium is a very safe gas. It's inexplosive, but it's very expensive, and it's also a non-renewable resource on Earth, which would arguably be best kept for more important uses, such as medical uses. Hydrogen has a much higher lift and is much cheaper, but it's explosive and it needs handling with more care. Aviation safety is another question which is often asked, and after all, the balloon flight area around 11,000 meters that we're aiming for is similar to the cruising altitude of commercial airliners. In this instance, it's worth remembering that around 650,000 weather balloons are launched annually, which is 1,800 daily from 900 locations worldwide. They're very much larger and much heavier than the tiny payloads we're talking about with these floater balloons. And yet there have been no reported incidents with aircraft since 1929, when the first weather balloons were launched. In most countries, such small balloons that we're talking about don't require any permission from aviation authorities to fly. There are also some bird species which fly at similar altitudes, such as Rappel's vulture, which is found at 11 kilometers altitude, where commercial airliners fly and these balloons fly, and they weigh 9 kilograms, which is again very much bigger than the 10 grams we're talking about here. I've also spoken with several commercial airline pilots over the last few years, and none of them had any concerns whatsoever about sharing their airspace with such a small thing. And they all thought that their plane would come out the winner if there was any interaction between the two, which itself is very, very unlikely. An important first question to answer is what balloons you'll be using to carry your payload. And Qualitex are a brand which is well known in America and Europe, and they supply suitable balloons in 36-inch diameter size, which we were using for some of the earlier flights. Party balloons are generally possible to use, but perhaps not the best, because they're not generally designed for low leakage, and the print on them necessarily adds a little bit of unnecessary extra weight. Certainly don't get the type of party balloons that come in all kinds of weird shapes and sizes, because the weight to volume ratio just deteriorates. We've had very great success, and in fact the best success, with Chinese balloons, which are very, very cheap. A 10-pack from China costs only $15 delivered, and so that's $1.5 per balloon. Very, very cheap, and they've also been found to be the most reliable that we've seen, with the least leakage and the least probability of bursting. So really, in this case, cheap is actually best. There's a Californian company, SBS, which makes balloons, very large balloons in fact, and they'll certainly get you to a higher altitude or allow you to carry a higher payload, but you'll be spending around $100 per balloon, plus a lot of extra money on the gas to fill them because they're much larger. And there is some evidence, at least on recent flights which I've seen, that the reliability is not particularly high. You can also make your own balloons to your own size and shape, and this was of course something that M0XCR did. He made his own balloons, and there's also more information on this in the accompanying conference proceedings article. Dave has had a go at this too. The other questions you'll want to answer is how many balloons you'll use. And so, of course, you could use more and more balloons, and that will allow you to have a higher payload or reach a higher altitude. But it will also give you a higher probability of failure, since if one of those balloons fails, your flight will come down. Pre-stretching is something that Dave has worked a lot on, and you can see in this picture some 4 balloons being pre-stretched in his house. He finds that this actually really improves the duration of the flights by preparing the plastic in advance, and it also achieves a higher float altitude. You also need to understand how much gas to fill the balloons with prior to the launch. There's spreadsheets available for calculating this, and again, look for more details in the article. Power sources are an important topic too, and unless you are only planning a very quick demonstration flight, you'll definitely want to have solar panels so that you can have a long duration flight and still be able to track your balloon. And so there are flexible panels, there are the glass panels. Generally, we've been using the glass panels. They're very, very thin and easily broken, but Dave has turned this into an advantage and figured out ways to cut the panels into smaller pieces so that he can reduce weight and still have adequate power to run the flight. Then there's the question of whether to fly with a battery or not. You can fly without a battery and just put a capacitor on the board, maybe a electrolytic capacitor, just to smooth out any power fluctuations that could be caused by the solar panels rotating in and out of the sunshine. And so, but if you include batteries, you will generally be able to get a couple of extra hours of flight time at the end of the day. So far, the longest we were able to continue transmitting after sunlight fell below the angle required to generate enough power from solar panels was about 4 hours. Generally, the batteries that we use, the lithium polymer batteries, do not do very well in extreme cold. And so in some cases, it gets too cold to operate before the battery runs out of charge. Nickel cadmium batteries have a much lower charge density, so a much worse capacity versus weight ratio, and nickel metal hydride are somewhere in between. So generally lithium polymer batteries are the preference because they have a very high power density to weight. However, published data is not everything, because of course that's at room temperature, whereas when we're up at 11,000 meters, we can encounter extreme cold, and nickel metal hydride and nickel cadmium actually do better in extreme cold than lithium polymer. So it's an open area for future experiments to see whether or not actually nickel cadmium would provide a better service in the extreme cold. Ultra capacitors are another option, but don't really have very much use after sunlight ends, because really the energy density is very much lower than batteries. Forecast tools, well, there are a very large number of tools which can be used to have an idea of where your flight is going to go next, which is always interesting. On the day of the launch, you certainly want to be very well aware of the weather, and remember that the weather at the ground is not necessarily the weather at 11,000 meters, and ideally you need a very clear path up without any clouds between you at the ground level and the final floating altitude at 11 or 12,000 meters. A tool which we use a lot is the NOAA model, which gives what we've found to be a very accurate projection over the next few days of where the balloon is going to go to next. There are also tools for visualizing the wind and the pressure isobars at different altitudes. And so these are all very interesting things to study and to learn about while tracking the balloon. There are a lot more details about these tools and links to the tools in the conference proceedings article which accompanies this talk. Testing, the importance of testing cannot be overemphasized. Test everything thoroughly on the ground, because you absolutely do not have the opportunity to go and visit your balloon for repairs when it's somewhere at 11,000 meters over Outer Mongolia. Testing in the cold is also worthwhile because some components and some faults may only come out when the devices are very cold. I would certainly think that doing it in the domestic freezer would be better than nothing. Dave took his testing to extremes with this 3-layered Peltier cooling device, which he managed to get things down below -50 centigrade. It's water cooled, it generates a huge amount of heat in the process of cooling a small chamber in the middle down to -50 centigrade. That was quite a huge project in its own right. In summary, and I would emphasize here that this is a huge topic and that I have only necessarily, due to the time limitation, scratched the surface, there is a very large article in the conference proceedings booklet which accompanies this conference. And so many of the topics which I've just briefly touched on here are gone into on very much more detail in the conference proceedings article, which is written partly by myself and also partly by Dave, VE3KCL. The U4B will hopefully be available soon and inexpensively from QRP Labs, and it only remains for me to warn you that ballooning is extremely addictive. I don't know of anybody, I think, who's only launched a single balloon. It tends to be quite an addiction. Ballooning is great fun and is educational, and ballooning is extreme QRP in every sense of the word. And now I believe we will have a question and answer session. Dave VE3KCL should also be here, available to answer your questions on the ballooning aspect, and I can answer any questions on the firmware and the U4B. I hope you enjoyed the talk, and thank you very much for listening.
Outstanding. Very good, Hans. We'll open things up to questions.
Thanks very much, Dave. I'll go through the questions that came through on the Q&A panel here. There were several questions which were actually already answered by the slides. Before I start, we do have Dave VE3KCL on the panel as well, and Dave is the guy who's done all the work with the actual balloons and the actual launches and antennas and all of this stuff. So if anybody has any questions on any of that, please do ask in the Q&A, and we can ask Dave to switch on his microphone and answer those. Apologies also for my bad audio quality. I'm a CW operator, and this webcam that I'm using has a really bad microphone on it, so I hope that it's audible, and I'll try and speak as clearly and as close to the microphone as I can. So Neil N9NL asks, do I sell a transmit controller? I think again this was already covered by the presentation. The U4B development is basically almost finished, and we consider the test series of the series of test flights has been successful, and as far as I can recall, we've never had a single failure of the software, never had the software hang up during a flight, even lasting many months. Currently we've got a flight which has been up for over 6 months and is on its 13th lap around the planet, and is somewhere over the North Pacific. It's quite amazing when you consider it's only a couple of $1.50 Chinese balloons holding that thing. And so as soon as we can get components again, I'm intending to get this tracker development finished and for sale inexpensively, as I mentioned. Currently, we are in the middle of a global semiconductor crisis, and it's almost impossible to get the necessary microcontrollers from any distributor. So that's that. Brian Bowling, permissions to launch a balloon. As I think I covered in the presentation, in most countries, the balloon is just so tiny and so light that you don't need any special permissions. In the UK, it's theoretically against your license to be able to do this. Then we have a question from Finland. OH6FJS said, could there be a QCX Mini with QDOS available one day? And it's the QCX Mini and the QCX series of transceivers use the Atmega 328 processor, and there just is not enough space on that to do anything more. It has a 32 kilobyte flash memory for the program, and there's no more space to do anything on that. But certainly it's my intention to incorporate QDOS or some variant of it in every future QRP Labs transceiver product which I design, which has sufficient resources to be able to use it. So that will include the forthcoming QSX all-mode, all-band transceiver. So as I developed the code for the U4B tracker, I very much had that in mind as well. And so the intention is that all of the user interface in the QSX will be defined by short programs which run in QDOS. So you can actually change the functionality and create your own functionality as you wish. Hazard to jet aircraft? Generally, no. The opinion is that they definitely not a hazard to jet aircraft. I even spoke to quite a few commercial pilots in Dayton over the years, and like everybody else, I very much hope to be back in Dayton next May and hope all this nightmare is over, and none of them had any concerns about safety. Eric, nice to see you here. Eric 4Z1UG, nice to see you here, my friend. And does the transmitter shut down if it flies over countries where amateur radio aeronautical operation is not permitted? No, it does not. However, if you wanted it to, you could easily do that, because you've got this is a technique called geofencing. So you have access to the latitude and the longitude and you know the countries that you want to shut down over, if you want to do that. Personally, I wouldn't bother with it, but if you really want to do that, you can implement geofencing and just cause it to shut down until you clear a certain latitude and longitude. So then Bob K2KI asks, have any flights been taken down by a country's defense forces? As far as I've ever heard, I've never heard of a flight being taken down by a country's defense force. As far as I know, I very much doubt that any military anywhere in the world would be able to target such a tiny and lightweight item as these balloons. We've certainly flown over North Korea, we've flown over Syria, we've flown over all kinds of war zones in the Middle East, and nothing has ever happened to any of the balloons. The only thing that we do notice is that there seems to be GPS jamming in some countries. The other day, Dave was mentioning to me, it seemed like we'd had GPS, no more GPS position fixes while it was flying over Syria. And so that does seem to be the case. Steve Roberts asks, are we using hydrogen or helium for the repeat circumnavigation journey? Dave is using hydrogen. Hydrogen is really not that bad if you look after it carefully, and it's certainly a lot cheaper. And arguably, helium is a very important non-renewable natural resource. You can't produce helium, you can only mine it out of the ground, and when it's gone, it's gone. And hydrogen also has other advantages too. It leaks more slowly because it's a larger molecule, each molecule consisting of 2 atoms bonded together. And it also has slightly higher lift than helium. So David's been using hydrogen, I think, since the beginning. John Putnam asks, how long does it usually take to get up to altitude? It takes, from memory, 3 or 4 hours to get up to 11,000 meters. And John Crabtree asks, how many balloons have you launched? Have you retrieved any? Now, I assume that you mean Dave and I have launched. Personally, I've launched none. I'm just the armchair balloonist here. But I covered in the presentation how many we had launched, and it's somewhere around 75 or 80 balloons. It's in the presentation. So, like everything else, please do refer to the conference proceeding article that accompanies this presentation, because it contains lots and lots of details which I have not been able to cover. Tristan says, Dave, what made you first launch a balloon? Dave, would you like to come in and answer that?
Well, it's simply for fun.
Okay. That's what it's all about. That's what our whole hobby is all about. And to me, I've never launched fun yet, but I do hope to one day. But fun is what this is all about, and what has got me interested in working with Dave on this too. Then John Putnam says, what about receiver that turns around and repeats info in the whisper transmitted, like a whisper repeater? And this was something that Dave and I actually did consider and did work on. And I designed a lightweight version of the original QCX transceiver with SMD components and cut out some pieces. And I was working on a special firmware version of the QCX transceiver that would actually decode CW and have QSOs with you, like a robot QSO with you, and would actually then make a log of all the contacts that it had QSOs with, and transmit this log back to the ground stations via the Whisper network. And so it's a very interesting thing, and I think it would be natural once the U4B is done. I think it would be natural next area to play with to have a balloon transponder of some kind, and I think that would be really fun to do. Maybe not just Whisper, and other things you could use, like JS8 Call, which has the message forwarding features built into it. So where are we? Is QDOS available for us to use, Brian asks. Only U4B is the first thing that will have QDOS in it. But it's a quite nice thing, and I think it would also be something I would consider, whether to make a standalone board